Victor, Christina, Jeremy, we're going to the moon.
This vehicle, along with about 8.8 million pounds of thrust, is going to accelerate the Artemis II crew here farther into space than we've ever sent humans before around the moon, back here safely to Earth.
We are going to, on this mission for the first time, test out the life support system with water delivery, oxygen delivery for the astronauts, so we're all excited.
This is just such a shining example of collaboration, and it just deserves to be celebrated.
This is a test flight. And so the activities that we do together, we are going to learn from them.
We have developed an integrated research campaign that will support all of our future Artemis missions to make sure that we can travel safely in space and bring everybody home.
Focus from every minute is going to be the most important thing. We're never taking a sigh of relief. We're never stepping back. We're bringing everything into this consolidated moment of performing in our time.
Christina and I may very well be the ones on the microphone when we're closest to the moon, so that we can put her eyeballs on the surface and I'm recording pictures and recording her, and those moments may change what we know about the moon, what we know about the Earth, what we know about our solar system and the universe. That's mind-blowing.
Good afternoon from Houston, Texas. You're looking live at the White Flight Mission Control Room, the science station specifically. The first time that this particular outpost has been added to the flight controllers' desks, as this unique opportunity for lunar science is coming back with humans in the loop for the first time in more than half a century. Good afternoon, everyone. I'm Will Robinson Smith, reporter with Spaceflight Now. It's wonderful to be with you just down the road from the Johnson Space Center. Going to be on camera just for a moment here. Let's take it back inside Mission Control Center Houston for the rest of our coverage here today, as we've got lots to explain, lots to talk about with the 4 astronauts who are about to make the closest approach to the moon that humans have made since the end of the Apollo era. And we're coming up in less than half an hour to the lunar distance record, as the Artemis II astronauts are about to pass the farthest point that humans have ever been from our spaceship Earth. They're going to beat the record set by the Apollo 13 astronauts, coming up here again in less than 30 minutes time. We'll be rotating through the various views that we have here to bring you all the best vantage points of both the spacecraft, the visualization like you're seeing right now, as well as onboard, inside, and external cameras to the Orion spacecraft.
Has the T-shirt shroud for the Z9 and solar, and then window 3 will be for visual observations, and window 4 is for floater.
And thanks Integrity for that, Reid. We had a handover during that time, so I'm going to have to ask you to give that read back on window orientation for the crew again.
Okay, we are happy to change it, but the way we have it configured right now is window 1 has a T-shirt shroud for the Z9 for solar. Window 2 has the shroud for the long lens for both lunar and solar. Window 3 is for visual observations. Window 4 is for floater. And then the docking hatch window has had a great view, so we've done a lot of mapping through that as well.
All right, copy all, Reid. A note just on the window 1 T-shirt shroud that you can remove that for the lunar observation block if you want that extra view for another floater, but defer to you guys on that. You are go to use the full 400 millimeter zoom on the long lens, but where possible, try to keep the end of the lens flush with the window to prevent imaging through the multiple window panes at an angle. And if you have to take an image at an angle, recommend you limit the max focal length to 200 millimeters or simply acquire the images at multiple focal lengths. Last imaging update as a result of the DFTO is that if you can take the images out of the left side of window 2 where possible, that is the best half the window. Understand that might not be possible with the shroud. Any other imaging questions from you?
Okay, copy that.
Okay, last couple reminders. Don't forget the ability to take the WAVE files to tag imagery that you are wanting to follow up on using the FN3 button on your camera. And then a couple quick notes on your LTP. We have refined your precise flyby timing since generating the LTP. Optimus has the correct timing for the LOS and AOS, but the LTP identifiers for LOS and AOS are roughly 2 minutes later than they will be in reality. Final LTP timing update is that the green line on your LTP should start automatically 45 minutes before the flyby. If it doesn't appear, let me know and I'll have troubleshooting steps for you. Last updates are on the eclipse, so only for that last hour today. Of course, remember if the sun is in view to use your eclipse glasses. And reminder that we will have a few activities for you prior to the eclipse to reconfigure all 3 cameras for corona and deep sky observations. These activities, some of which will occur during the forward link LOS, so we wanted to flag it for you now. Any questions before I cover the last 2 reminders?
No, we have no questions on that.
Last couple eclipse reminders, the sunset period and the first roughly 23 minutes of the eclipse will fall during that forward link LOS, but we'll still have a return link and we're still looking forward to your science sit reps and observations during that time. And I do have a reminder for you on your preferred starting config for the eclipse in terms of role responsibility. Let me know if you want me to read that up or if you guys have that in your minds already. And if no other questions on config, I'll give you a few science-focused reminders.
Give us a quick high level, but we see it in Optimus, and I think we got it squared away. But give us your quick Kelsey high level.
Okay. A couple changes from the first LTP you studied is that Glushko is the only feature that the same pair will view twice. That's Reid and Jeremy. That's why that's the only target you see that is marked as 1 of 1 and 1 of 2 and 2 of 2. So Ohm and Oriental are in there twice, but they're by different pairs, which is why you don't see them marked accordingly. A note from feedback on your observations so far over the last couple days, a reminder that if you note structure and texture as well as color and albedo, please note any correlation between the 2, and also a reminder that negative observations are still valuable science. So a lack of color or a lack of structure associated with color is also valuable. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture. Any other questions for me?
Kelsey, hey, when you're talking window 2 left and right side, just can you say towards window 1 or towards window 3, and then we'll know that we are talking the same language?
Absolutely. So I mean that the side of window 2 closest to window 3 is preferred for imaging.
Okay, the side of window 2 closest to window 3 is preferred for recording. Stand by, we'll talk to the crew.
You're listening to communications between the lunar science lead that is on the right-hand side of the science desk in the White Flight control room. That is Dr. Kelsey Young. She's been communicating most recently with Artemis II commander, NASA astronaut, and former head of the astronaut office, Reid Wiseman.
Kelsey, for the T-shirt shroud, what window does the science team think will have the best view? Is it window 1 or window 4?
The only time we're strongly recommending use of the window shroud.
Eclipse. The T-shirt window shroud for the eclipse viewing. Which window is primary for Z9?
Window 1.
Okay, awesome. So we have got that all set up. And just to be 100% sure, window 1 is the most port window by the food warmer. Window 2 is right in front of seat 1. Window 3 is right in front of seat 2. And window 4 is on the starboard side by the side hatch. Do you agree with all that?
We agree on the ground. Good readback.
Okay, that's awesome. Kelsey, we're going to close with happy words. It's just incredible. I wish you were up here to see all the smiling faces, to hear all these terminologies being thrown around, and we are just fired up to get started on this day. Let me pass the mic around if anybody has anything to add.
Kelsey, it's so great to hear your voice on the loops. I just want to channel everything that you guys are probably feeling right through my eyes and heart. It is awesome to see the side of the moon. You guys made us excited for this day, and we couldn't appreciate it anymore. And we are ready to hopefully deliver on all the awesome training you guys have provided.
I'll just add, Kelsey, it is blowing my mind what you can see with the naked eye on the moon right now. It's just unbelievable.
Kelsey, and to the whole Lunar Science team, all of you, all the work you put into this, we're just grateful. Can't wait to get going. And thank you for the tipper, for Carol Crater, and for Integrity. We can see them, and we've imaged them, and can even see with the naked eye. Quite impressive. Thank you so much.
Beautiful words, you guys. Thanks so much. And I got video of the science team right now, and they are all absolutely buzzing. Looking forward to today.
Okay, we're heading into the timeline. Cheers, guys.
Good words between all 4 members of the Artemis II crew, and again, that was Dr. Kelsey Young speaking from the ground up to the 4 Artemis II astronauts. Dr. Young is the Artemis II lunar science lead for this mission. The scientists that she was referring to are in a couple of different rooms right now. You're taking a look inside one of those. This is where all the science data is coming down and being processed in real time as the Artemis II astronauts are making verbal callouts and sending down notes. As you heard, they'll be doing this in a series of shifts with one person in the window that is making observations and shooting with the camera. They've got a couple of different camera options. I've got a nice graphic here. This is the science evaluation room of the SIR. There's also another support science room that is not currently on screen, but we had the opportunity to visit earlier today and talk with some of the science team. That is the acronym called the SMORE, which stands for the Science Mission Operations Room. That's in Building 36 over at the Johnson Space Center. As the photos are captured by the Artemis 2 astronauts and downlinked, that will a lot of the images that are captured tonight will be downlinked following the flyby in order to keep the crew as plugged in as possible. They've got a busy schedule ahead of them, and as the images are processed, then they will be shared with the public. We've heard from Dr. Young that she is expecting the Artemis 2 crew to capture upwards of thousands of images throughout the course of this multi-hour flyby experience. So lots of great opportunities to both learn from a science perspective and for the broader space-loving community to just be in awe of our first opportunity to see lunar photography captured in the 21st century from the lunar sphere of influence. Mission elapsed time on the Artemis 2 mission currently 4 days, 19 hours, 13 minutes, 36 seconds, and counting up as the crew have been busily working on understanding about how the Orion spacecraft works and operates in the deep space region beyond Earth's gravitational influence directly, closer to the lunar environment. For those who may just be dipping into the whole Artemis 2 affair, just as a quick table setter, if this is your first time really paying attention to what's going on, don't feel bad, you came in at the right time. This is going to be the most visually stunning day of the mission as far as...
Integrity crew, we have Reid's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in mission control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reid. Copy heart, copy bracelet.
And some good words from the ground to the Orion spacecraft, letting them know that Commander Reid Wiseman's family, at minimum his 2 daughters, are in the gallery of the White Flight control room, or the FICR, as it's known. Calling an audible, Stephen, if we can go to JSC4, the view from looking at the cap composition. So if we don't have a wider shot here, this is a good one just to talk about what the gallery is here. Just behind that back row of flight controllers, there's a series of chairs and a big window looking down on the white FICR. That's known as the gallery space. It's not quite perfectly soundproof, but largely soundproof, and allows special guests and folks like us to be able to have a chance to peer in to what's happening here in real time. We were there during the period where the crew was just about to wake up. So about an hour before the crew was woken up with a lovely message. Of course, the Artemis 2 astronauts have had the ability to choose all of their own music to wake up to on the daily, but the team here on the ground have done a stellar job of weaving in some very special messages from the astronauts of the Apollo era of audio passing of the torch, if you will, from the last generation of lunar explorers to this new Artemis generation. Today, the message came from the pilot of Apollo 8, Jim Lovell. It was recorded back in 2025 before he unfortunately passed away and was not able to see the Artemis 2 mission in flight, but the crew got to experience the wisdom of Jim Lovell as they're flying a similar mission to Apollo 8. Of course, Apollo 8 went into lunar orbit. This is a free return trajectory. That means that when they completed the translunar injection burn a couple of days ago, that set them on a path that will see the Orion spacecraft make a loop around the moon and then come on back to Earth. Essentially, actually, if we can go to this video or this image here, this graphic showing the trajectory of the Artemis 2 mission, they're more or less making a pretty darn straight shot, a little bit of curve, as you can see, but essentially they shot away from the Earth, and when they go out into the path of the moon's orbit, the lunar gravity taking over enough to create that loop back to Earth, but the distance that the Artemis 2 astronauts will be from the moon means that the gravitational pull of the moon is not going to be strong enough that it would pull them into lunar gravity, and they're going too fast for them to be caught by the moon, and so it just creates a big slingshot back to Earth. And they'll splash down off the coast of San Diego as currently planned on Friday, April 10th. The graphic that you see of the moon there on the left-hand side, that is a graphical real representation of where the moon is in relation to the Orion spacecraft as well as to the Earth. Part of today's mission will see the crew conduct, of course, the lunar flyby, and their closest approach will be about 4,000 statute miles above the lunar surface. They will also be, as part of this flight plan, be able to observe a solar eclipse. So the moon will be obstructing the sun completely from their vantage point, which will also give them a unique chance on the moments of sunset and sunrise, if you will, from an eclipse perspective, for them to do some imaging of the solar corona as it peaks around the moon's surface, as well as to get some distinct illumination on the lunar backside as the crew will see it from the vantage point of the eclipse event. Coming up here in just about 1 minute's time, the Artemis 2 crew is expected to pass the distance record set by Apollo 13, and we're expecting to hear some words from the ground and words from the crew themselves. Some NASA leaders like John Honeycutt, who chairs the mission management team, says that while these types of milestones are certainly neat, what he cares most about is not the breaking of records, but making sure that these 4 souls make it safely back home aboard their Orion spacecraft. Again, splashdown is set for Friday, April 10th.
Integrity crew, on April 15, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from cabin of integrity here as we surpass the furthest distance humans have ever traveled from planet Earth. We do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived.
Thank you, Integrity, and congratulations to you and the rest of the Artemis II team.
Thank you, Houston. We have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reid, the mother of Katie and Ellie. And if you want to find this one, you look at Geological, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
Some beautiful words from the Artemis II crew and a couple of suggestions for future crater names, as you heard. The first named after their spacecraft integrity. The second, as you heard, an emotional moment and certainly understandable. Carol Taylor Wiseman was the wife of Commander Reid Wiseman, who passed away after a 5-year battle with cancer. So a beautiful moment for the crew, and certainly if it's accepted as a new name for that crater near the near side, far side boundary, a visible reminder for these 4 brave souls who are embarking on the Artemis 2 mission, and for all of Reid's family to be able to look up at the moon and think fondly of Carol. There's, I'm sure, an official process for how all this works, but speaking singularly for myself, I'll give my vote of support for that suggestion.
All right, Houston, we're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you are maneuvering to your observation attitude.
time now 1:10 p.m. Central Time, 2:10 Eastern, 18:10 UTC for those joining around the world. If you're just now hopping into the live coverage here, welcome. You're watching Spaceflight Now's dedicated live coverage of the flyby of Artemis 2, making its closest approach to the lunar surface that it will conduct on the Artemis 2 mission, a period of lunar observation for which the crew has been training for years, going through various trainings in the realm of geography, of lunar science, understanding the regolith and various geological terms, understanding the types of details that they may see as they're looking down on the surface of the moon, and also making observations about how they're experiencing this whole affair as the first humans to enter into what is known as the lunar sphere of influence since the Apollo 17 astronauts left in 1972. As the crew is approaching the closest they will be to the near side of the moon, they have, of course, surpassed the distance record set by the Apollo 13 astronauts. That official time of passing that record was 1:56 p.m. Eastern, 17:56 UTC. During Apollo 13, that crew traveled 248,655 miles from Earth. The distance record will continue to be broken, and we'll get official final numbers once they do make that furthest point passing by. As you can see, the moon is growing larger for the cameras that are on the outside of Orion, and of course for the crew inside the spacecraft. For a sense of what this is like for the Artemis 2 astronauts that are preparing to make the important lunar observations here in the hours to come, if you imagine holding a standard basketball in the palm of your hand and then extend your arm to its furthest point away from your body, that's about what the moon will look like for the Artemis 2 crew. The crew is set to make their closest approach to the lunar surface, which is about on the order of 4,000 statute miles. That's set to happen at about 7:02 p.m. Eastern, 23:02 UTC for those joining around the world. Speaking of joining around the world, we want to thank the more than 7,100 of you who are watching along with us live today. We certainly appreciate your time and attention. It's been quite an honor and a privilege to be covering this piece of history for you all. Certainly a team effort to make this coverage happen, and we appreciate your being here with us as a part of documenting history. The opening of the show was a bit busy, so just to get the table setters out of the way, if you haven't already, you could do us a big favor just by clicking the like button here and sharing this stream. That will allow some more folks to find their way to this live lunar flyby coverage. We also want to extend a big thank you to our team back in Florida who's supporting us on a technological frontier to make this live stream possible. So big thanks to our Spaceflight Now editor, Stephen Young, alongside our extraordinary photographers, Adam Bernstein and John Pisani, hopping in various capabilities to make sure that we've got good, robust coverage for you today. As we did earlier in the show, we will do our level best to not step on the Orion to Earth communications. We, along with you, dear viewer, want to make sure that we are hearing what's being communicated to the crew as well as everything else that is happening with this mission in the flyby. We'll be bouncing back and forth as the views look the most interesting between the real onboard cameras on the Orion spacecraft as well as within the Orion vehicle, and computer representations of the flyby, as you can see with this visualization that was created by NASA to give you a crisper view that gives you a little bit of a third-person perspective of the orientation of Orion, both the European service module, which you can see that's the part with the main large engine nozzle, as well as the supporting smaller engines. That is the cylindrical piece of Orion, and then there's the stage adapter in between the service module and the crew module up top, and you can just barely make out a little bit of the top of the crew module here in the visualization if you look near from this orientation, what I'll just call the bottom of the full Orion spacecraft from this perspective. Back here in Mission Control Center, Houston, this is the White Flight Control Room, or the White Ficker, where we're looking at the Capcoms for today. This is the station that primarily is in charge with communicating with the crew members on board the Orion spacecraft. Now, the team goes through a rotation series with all of the positions in the control room here. That's in order to make sure that everybody who is on console is fully rested and ready to support all the various needs and impacts to the mission in all the various capabilities. If you look in the right side of the screen, actually before we pivot away from the position where we're currently in here, of course, we're on Monday, April 6th. The two Capcoms that are currently in that position, they're not always going to be astronauts, but in this case, they happen to be for this particular, what are called orbits. You could think of them as first, second, and third shift. But for orbit number 1 today, we have on the left-hand side in the blue shirt and the red tie, that is NASA astronaut Stan Love. And to his left or right in the charcoal gray jacket, that is Canadian Space Agency astronaut Jenny Gibbons. Gibbons trained to be one of the two backup astronauts for the Artemis II mission, alongside NASA astronaut Andre Douglas. As the day goes on and we see a crew shift here in the White Ficker, again, we're currently in what is referred to as Orbit 1. Taking over in Orbit 2, which will be sort of the middle of the day for the Artemis II crew from their perspective, we'll see Tess Caswell take over, who is the lead Capcom for the Artemis II mission, alongside the aforementioned Andre Douglas. To the right, the gentleman in the, some people may quibble with my color description, I'm going to call that maroon shirt. Taking a bite of lunch as we're currently at 1:19 p.m. here Central Time. If I wasn't on the mic, I'd be doing the same, taking a bite of a cold wrap that is sitting in the fridge beside me. Hopefully I'll take a moment to steal away and grab a little lunch myself. But that is Jeff Radigan, one of the flight directors who is supporting the Artemis II mission. Just as a table setter for what we are expecting schedule-wise with today's flyby operations, of course, it's 1:20 p.m. Central Time here in Houston, Texas, 2:20 p.m. Eastern for all of our friends back in Florida, as well as along the East Coast and in just the broader Eastern time zone, 18:20 UTC for the rest of our viewers around the world. All these times I'm going to mention are in Eastern time for the sake of brevity and for everyone's understanding. Coming up in about 25 minutes time at roughly 2:45 p.m. Eastern, that's when the official lunar observation period, shorthand the flyby, that will take place beginning about quarter till the top of the hour. As we heard from the Artemis 2 lead science position that is currently here in the science seat in the white Ficker. That is Dr. Kelsey Young. She reminded the crew that it will take time for their eyes to adjust, as we will hopefully get some camera views back in Orion at some point in the not too distant future. They will be dimming the lights in the crew cabin there in order to make sure they've got the best optical viewing for the cameras. As our photographers Adam, John, and Michael can attest, the worst thing you want to have happen in a situation like this when you're shooting out of a window is to have any kind of glare. So the crew have been training in order to shoot through the windows of the Orion spacecraft. One of their notable training sessions happened back when they were here at the Johnson Space Center in a facility called Building 9, where they have a number of big mock-ups for various astronaut training exercises. And next to what is called the medium fidelity version of the Orion spacecraft.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reid 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2. And Earth out window 4 and Moon out window 3. And it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reid.
And as you've been hearing from Commander Reid Wiseman, capturing that majestic view, and you can just imagine all of the wonderful photos that will be shared throughout the course of tonight and into the day tomorrow, as all the high-resolution images, or a good chunk of them, are downlinked and able to be shared with the public. Some of the other communications you were just hearing between the Capcom on duty, Jenny Gibbons, and Christina Koch, mission specialist on board the Orion spacecraft, reading off the various serial numbers for the SD cards. Again, as the photography community can attest, one of the worst bits of happenstance is when you're quickly working through a project and you're bouncing around different cards and things get put in one place or another and you forget whose is who, and you have to plug it into a computer to figure out. They're trying to mitigate all of that by making sure there's a clear understanding of who's managing which SD card into what camera that's going, so that when they downlink these images and are able to start processing them, they, on board Orion, know whose is who, and then down on the ground they can identify which crew member shot what photo. So you'll hear lots of little detaily things like that as we go throughout the coverage today, as the crews are making sure they're being thorough in their lunar observations and thorough in their media management. We're less than 20 minutes away from the point of the lunar observations starting. I want to thank a couple folks in our live chat for your support of our flyby coverage today. Thanks to Jane Rankin for the £2 super chat, who says, "So excited. Thanks, Will, for all you do." Well, thank you for the kind words. I will extend that out to the Spaceflight Now team. This is very much not a solo venture making this all happen. Want to welcome in new channel member JMD Manch, or Manche. Apologies, JD, or JMD, if I mispronounced your last name there, but thank you for joining at the pad leader level and then upgrading to mission specialists. We certainly appreciate all of you who are able to support us at the higher level. That allows us to keep our entry level for membership at the current level it's at. Also, thanks to Nacho Broyan for gifting 10 Spaceflight Now memberships. We really appreciate that generosity. And to all of our newest gifted channel members, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Nacho in
Houston Integrity for attitude.
Go ahead.
Hey, Jenny. Understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
Copy.
mission elapsed time for the Artemis 2 mission, currently 4 days, 19 hours, 54 minutes, 47 seconds, and counting up. Very cool super chat coming in that I'm seeing here. Cynthia Nielsen with the $5 super chat. Thank you, Cynthia. Saying, "So awesome. My uncle designed the camera that first went to the moon. He is seeing this today. Go Artemis 2. Well, that is extremely cool, and please give your uncle our warmest wishes. And
Houston Integrity for timeline.
Go ahead.
Hey Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well.
The communications that we were just hearing from...
Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
Couple things to pull out of those last words we were hearing from Christina and Jenny. Jenny Gibbons, the Capcom on the ground here in the White Flight Control Room, and the, of course, Christina Koch, one of the mission specialists on board Orion. The LTP that was referenced a number of times, that is the Lunar Targeting Plan. There are a series of 30 points of observation that the science team have picked out and curated and given to the Artemis 2 crew that they want them to most specifically hone in and target as they make their way through this multi-hour period of lunar observation. The comments that you heard regarding the first discussion, which is coming up here in a little bit at 1845 UTC. That is a series of, it starts the point of science observation and focus, and helps both the team on the ground and the team on the Orion spacecraft have a roadmap, if you will, of where they will be honing in on. So the first discussion, as they're calling it, is a general welcome, bringing the focus of this part of the mission really into clear understanding for everybody. It's kind of a table setter, if you will, for the start of the observations. Then they'll make a discussion point about the near side versus the far side.
Houston integrity, if we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
For those unfamiliar with the type of terminology.
So, Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
Again, we're pausing to make sure we're not stepping on those Earth to Orion comments between Capcom, Jenny Gibbons, and whoever's speaking from the Orion spacecraft. Just a quick note on the verbiage. We're hearing the pitch and the roll. The pitch is the upward and downward movement of, in this case, the Orion spacecraft. And the roll refers to the tilting side to side. That happens along the longitudinal axis, or in this case for the Orion spacecraft, from the top of the crew module down to the nozzle of the main engine. The crew has done a series of manual piloting demonstrations. First one with test pilot, NASA astronaut, and Artemis 2 mission pilot Victor Glover. That was in the short aftermath following separation from the Space Launch System rocket's upper stage, called the interim cryogenic propulsion stage. They did a series of maneuvers, both looking back straight down the ICPS after making a 180-degree flip. And then the spacecraft maneuvered to the side of the ICPS and did some more positioning demonstrations, moving along the 6 degrees of freedom. That includes pitch, roll, and yaw. As well as moving forward and backward, side to side, and up and down. The official start of the observation period is coming up in the next 5 minutes. Just wanted to go back and close the loop on one of the super chats I read a second ago from Cynthia Nielsen, saying that her uncle designed the camera that first went to the moon, which is extremely cool. assuming that is the Hasselblad 500 EL camera that flew on Apollo 11. And you'll have to let me know in the live chat if I'm correct about that, or if you're referring to one of the cameras that was used during the Apollo 8 lunar flyby, or Apollo 8 mission, which went into lunar orbit. As we're waiting for the lunar observations to begin and those callouts to start coming down, thanks to Mike Schmidt for the €2 super chat and then a €3 super chat. Thank you, Mike. Our thanks as well to Melanie Watts for a $10 super chat, who says the Wascom, Texas 5th grade science class wishes you a safe and happy Taco Monday and a good trip. Or safe trip, happy Taco Monday. Yes, love the combination. And now you're making me even hungrier. So appreciate the support today. And a big hello to all you 5th graders at Wascom Elementary. Thanks for watching, and we hope you learn a thing or two about exploring the moon. And hopefully this will inspire some of you to go out and chase your dreams, and perhaps have the privilege of talking to a future NASA astronaut. You never know what'll come down the road for you. Also want to welcome in, or thank Ken Urbanek, one of our channel members, for being with us now at the pad leader level for a full year. Saying thanks, Spaceflight Now, and our moderators. Thanks to channel member Rolly Nevels for the $2 super chat. Says, hey, Will and Spaceflight Now. Thank you so much. Thank you, Rolly. Another channel member, MedTech, with the $20 super chat. Very kind of you, Med. Who's sending virtual Kalashkis for the Spaceflight Now team. Says thanks for the great coverage. Last comment for now, saying this is from channel member I'm Lita, the $5 super chat. Thank you, Lita. Good to see you. Saying another historical moment with the Spaceflight Now family, Will, team, and the mods. And yes, it is an honor and a privilege to be covering this moment in human spaceflight history with all of you. And thanks for stopping by for at least part of it in your Monday mid-afternoon for us here in the United States, and for all of you around the world checking in on this historical milestone.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Oriental. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina, thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Oriental. Great words.
Mission elapsed time on the Artemis 2 flight, 4 days, 20 hours, 12 minutes, 57 seconds. The Oriental basin that was just referenced, described as the youngest large basin on the moon with a dark impact melt interior, bright rings, and a prominent ejecta with secondary crater chains. As we're looking at the moon from the camera perspective here on Orion, the Oriental basin, if you see the right before where the shadow region of the moon is.
One report from the crew at the windows. We can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view. So you could think that your eyes focus for the darker sky, and that means that it only has apparent brightness more than the moon. But since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
Of course, the NASA astronauts and the Canadian Space Agency astronaut on board Orion are conducting lunar science right now, and so you'll hear a lot of terms that don't get thrown about in casual conversation, like albedo, spelled A-L-B as in ball, E-D as in dog, O. The way that NASA describes the term albedo is, quote, a measure of the percentage of sunlight that a surface reflects away. So if you think about, as they describe in this example, fresh snow having an albedo of about 0.85, or in other words, reflecting about 85% of the sunlight that hits it. You may think back to a time where you've been out in the snow, whether skiing or snowboarding, or just inundated with snowfall around your neck of the woods. Think about how bright it is outside when you look down at the snow, because it reflects a lot of the sunlight back up at you. Conversely, the other example that NASA gives is the open ocean having an albedo of less than 0.1, meaning that it is absorbing more than 90% of the incoming sunlight and reflecting less than 10% of that back at you. So when you heard Christina describing the albedo of the Earth, that means that the light reflecting off of the Earth that is facing the Orion astronauts right now is considerably more so than the albedo of the moon. All of these observations are going to be closely studied and discussed by the principal science team here on the Artemis 2 mission, as well as researchers around the globe, as we work to learn more about our own satellite, the moon. One of the reasons why it's important for researchers to learn more about the moon and why it's such a point of scientific fascination, as well as, of course, the beauty and cultural significance that the moon has for cultures and regions of the globe, is that the moon is essentially a geological record of our place in the universe, the various impacts and things that have been experienced in our region of the solar system and the Milky Way galaxy. Things that the Earth largely encounters are things that the moon encounters as well. The difference is we have a lot more, of course, we have vegetation, we have our oceans, we have human activity, and our atmosphere, all of which plays a role in shifting how our Earth has changed over millions of years. The moon, however, is a more pristine record keeper of some of these various impacts and what has come through the cosmos and entered into our celestial neighborhood. And so with things like lunar sample return and with the observation that the Artemis 2 astronauts will be making with their eyes, they'll be able to, as expected, pick out certain colors on the lunar surface.
Science from integrity. We have a SITREP. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reid in window 1, having a great discussion. Christina's under window, I'm sorry, Reid is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science SITREP, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess Alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the west, sorry, to the east was still dark, but maybe a 7, 8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side, there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
Those words exchanged from the Orion spacecraft and NASA astronaut mission pilot Victor Glover and Dr. Kelsey Young, the lead scientist on the ground in the white flight control room, or the white figure that's in the new position for the Artemis 2 mission that did not exist on Artemis 1, given that there were no humans on board to relay science data down to the ground. And this is a new capability that is built into Artemis 2 and will continue for further missions. Just as a quick reference point, as we're looking at these views of the moon from one of the external cameras on the Orion spacecraft, if you see the larger sort of grayish piece of the moon, hang on, I'm pulling up my own lunar notes here. If you look at the right side of the moon from this current orientation, and you see the very distinctly large, darker region of the moon, the very edge of that on the left-hand side of that large, dark, and I'm not going to use all of the specific scientific terms that we're going to hear from the crew and from Dr. Kelsey Young. I'll try to make this a little bit more layman for everybody that is joining around the world. So the larger, darker region, the furthest left of which is the Marius Hills. If you look just beyond that and then bring your eyes down towards the bottom half of the moon there, the reference to the Grimaldi Basin, that's the little...
Houston Integrity was able to, Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get two eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light the low sun angle, and so where the Vavilov has that impact over the top of another crater, where the two craters intersect on the eastern edge. So on the side closest to Oriental, where the two crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely, we will do. Thank you.
Just to hop in quickly, because the communications will be coming at largely unpredictable times from Orion to the Earth. The Grimaldi Basin that you heard Victor describe, not in this past communication, but the one before that, that's the little gray shaded region that is just off of the edge of the much larger sort of charcoal gray part of the moon from this camera's perspective. And then if you keep your eyes going just to the left of that, move laterally about halfway across the moon, you can see that larger sort of ring. You can see the darker region surrounded by a couple of rings beyond that. That is the Oriental Basin, which is described by NASA as the youngest large basin on the moon, with the dark impact melt interior, which creates that different color that I was just describing, featuring the bright rings and prominent ejecta with secondary crater chains. One of the unique parts of the Artemis 2 mission is when they launched, they had a different science objective than the Apollo missions of yesteryear, where the Apollo crews wanted to maximize the amount of sunlight on the near side of the moon so that they could have missions of varying lengths. The goal, in part, of the Artemis 2 mission is to be able to make observations of the backside of the moon. You're taking a look here at the couple of different cameras bouncing around. Actually, Stephen, if we can go to the shot that is in preview right now, bring that back. This is the view from the perspective. It's a little bit, this is within the white flight control room. But if you remember, for those who were with us earlier in the broadcast, the gallery where Reid Wiseman, the commander's family, is sitting, that is almost immediately behind where this camera is positioned. So just to give you a sense of orientation of what we're looking at here in the room. You can see the screen on the right-hand side. That was the, well, if it gets brought back, that was a representation of some of the science targets for the Artemis 2 crew, back now on an external camera view of the Orion spacecraft. When they launched on April 1st, they were tracking a couple of different opportunities with it. Well, let me back up. Before the Artemis 2 mission launched, depending on when they were going to launch, that set up how much the far side of the moon would be illuminated, and therefore determine A, how much the crew would be seeing, and B, as a follow-on to that, what types of science targets they would ultimately be selecting for the crew to kind of focus their attention on. And so when the Artemis 2 crew ultimately did launch at 6:35 p.m. Eastern, 22:35 UTC on Wednesday, April 1st. That set up the trajectory for this mission and the opportunity to see the moon illuminated at about 20%. What you're seeing right now is a quick couple of glimpses inside the Orion spacecraft. The red light that you saw are one of the headlamps for an astronaut. Unclear who that was. As you heard from pilot Victor Glover, they have turned off all of the cabin lights in order to create the best possible lighting conditions for the astronauts as they make these critical science observations for the team on the ground. As is the case with astronauts who are on the International Space Station, the benefit of having humans in the spacecraft for the Artemis 2 mission and future missions out to the moon is that they are able to train these 4 individuals and allow them to act as field scientists. I mentioned that covering the Artemis 2 mission is a team sport, and it very much is, as we're focusing our attention in a couple of different directions here at Spaceflight now. I've got Adam and John, who are normally our photographers, running in a quick response research and technical support capacity, so we really appreciate them for helping out our editor, Stephen Young, and myself as we all juggle this multi-hour lunar flyby mission and make sure that we're bringing you the best and most robust possible coverage. The quick reference I wanted to go back to that Adam was able to track down, so thanks for that, Adam. Victor made a reference to the Vavilov crater, spelled V-A-V-I-L-O-V. That is to the west of a plane called Hertzsprung, located on the far side of the moon.
In science integrity, looking at a window 1, I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And Korolev is now a few degrees from going over the horizon. And then, you know, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. It looks like we have about 80% illumination of the moon. And Vavilov and 1 Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Oriental, and just around Oriental, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature I cannot remember, Burgess Alpha, and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Oriental. Also, an interesting part of the discussion that I heard between Reid and Jeremy is that from Geological to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Geological, is also that same dark albedo. And then around them, there are some very high albedo spots just to the north of the southern one, and just to the west of the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up on in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of a very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aitken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see. Just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. A very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi, and notice that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
Lots of great science descriptions coming down as you've been listening to, or we've all been listening to, NASA astronaut pilot for the Artemis 2 mission, Victor Glover, communicating with Dr. Kelsey Young, the Artemis 2 lead scientist. The Lunar Science Lead is her official title here. Just as a way to reference where we are in the timeline of things, the Artemis 2 astronauts are now less than 10,000 statute miles to the moon. Again, just to be super clear for folks that might be passingly paying attention to the Artemis 2 mission, this is not setting up a lunar landing. That will come beginning as planned with Artemis 4 now. Will be the first lunar landing of the Artemis program. This is it's called a free return trajectory, where the crew will loop around the moon and then begin to start making their way back to Earth. Coming up at 6:44 p.m. Eastern, that is the predicted loss of communication with the Orion spacecraft, which will last about 40 minutes time as the crew goes around the back of the moon and will be in a comms blackout with the ground. Again, this is expected. Eventually, though, with future missions to the moon, the plan is to get communication relays in place in lunar orbit so that operations can happen on the lunar far side. And when you have these transits around the moon, NASA and the partners will not ever be in a communications blackout, whether it's with an Orion spacecraft, with one of the two landers for the human landing system, or one of the robotic landers that are coming from the various companies participating in what's called CLPS, which is the Commercial Lunar Payload Services Program. In fact, one of the CLPS missions that is set to fly this year comes from the company called Firefly Aerospace, based here in Texas. Blue Ghost Mission 2. Blue Ghost is the name of their lander, which, fun fact, Blue Ghost is a type of Firefly, which is why the lander got its name. Blue Ghost Mission 2 is set to fly to the far side of the moon, and the Artemis 2 crew is actually set to encounter one of those, or the landing spot planned for that lander.
And science, integrity, that crater to the north, that is, it's like we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3. But it is very bright and it stands out. And then between that crater and the actual, what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again another 2 albedo surrounded by 5, and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
topography comparisons, absolutely. And if you have any idea what, if you draw a line between Pythagoras and the western edge of the outer defined ring of Oriental, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the Terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south, if you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth, draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little Terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south, all around the South Pole. And at the North Pole, it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The 2 observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and Science, Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit, it's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses, and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Communications between pilot Victor Glover and Dr. Kelsey Young, the Artemis II lunar science lead. I was just hearing from Victor there that peering out at the moon, as bright as it is, and then coming back inside where all the cabin lights inside the Orion spacecraft have been dimmed to allow for the best possible lighting conditions as they make these crucial science observations. The folks that we've been hearing on the mic, Christina, Koch, and Victor Glover, who are communicating with both Houston. The calls to Houston is to Jenny Gibbons, the Capcom in the White Flight control room. And when you hear the call for science coming from one of the astronauts on board Orion, that is communications with Kelsey Young, the Artemis II lunar science lead. Dr. Young making the offer that if the Artemis II crew so decide, instead of going back and looking at the PCDs or personal computing devices, which are the tablets that they have inside the Orion spacecraft, they can instead have the science team, in this case Dr. Young, make the call about the upcoming targets that they are focusing principally on as they continue this lunar flyby period. The clock in the upper right-hand corner of the screen, we've adjusted that instead of the mission elapsed time to being the time until the closest approach, which is just under 3.5 hours from now. I want to bring your attention to a new graphic that will be popping up as we continue through the coverage here. This is the, let's see if I can make the switch here. This is the series of principal targets that the crew are most explicitly looking at throughout the course of the lunar flyby. You can also see the relative position
of another observation, whole moon. When you look at the moon, something I've never seen in photographs before, but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
The swap that was just referenced, and the reason you've only been hearing so far during this period of observation the voices of mission specialist Christina Koch and pilot Victor Glover is because Jeremy Hansen, the other mission specialist, and Reid Wiseman, the mission commander, have been glued to the window and been working in tandem to make photographic depictions of the moon, as well as calling out and giving really detailed verbal recording of what they're observing. And so the two people at the windows are most explicitly focused on that. And then you've got, in this first wave, you had Victor Glover and Christina Koch, who were able to listen in and then come back a little bit further away from those recordings and communicate down to Dr. Kelsey Young, the lead science, or the lead for lunar science, about what's happening in real time. So you've got a couple of different ways that they're collecting this science contemporaneously. The recordings that are happening with the two that are positioned at windows number 2 and number 3. And then you've got folks that are making the calls down to the ground to make sure that the science team is as in the loop as possible with what the crew is seeing and understanding, the characteristics that are jumping out at them that really can be best experienced by the human eyes, which is why they've sent these 4 humans on this lunar journey in the mission designed as it is. The big graphic that you see on your screen are the various targets that they're going through, and the ones that are in blue they've gone past those as far as principal targets, and what is highlighted in green, I believe, is what is in focus currently.
Houston integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had. And the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing, even on the western side. And the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
For a reference point, vis-a-vis the latest discussion that was just had between NASA astronaut Christina Koch and Dr. Kelsey Young, the Artemis II science lead, lunar science lead, Mare Imbrium, spelled I-M, B as in ball, R-I-U-M as in more, that is described as the largest basin on the near side of the moon, with a diameter of about 1,160 kilometers. It's about half the size of the South Pole Aitken Basin, which is on the far side of the moon.
Houston integrity, science integrity. A question and a comment. Question is it possible that we're seeing Schrödinger Basin from this vantage point in the Terminator at the South Pole? And the comment is the rays coming out of Ohm are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out. It's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of Ohm rather than sort of albedo. And as answer to your question, we do not think you can see Schrödinger. It's in darkness as of now. But thanks for that Ohm description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole, where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
And Integrity Science, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in the eliminated portion next to the terminator?
And Science from Integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly. Integrity Science, we believe that's Zeeman Crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman Crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing. But I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Science integrity. Wow. Yeah. I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. It looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there, 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the Terminator because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science. Oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
Boy, if you ever wonder why the 4 members of this crew were selected, you got a really good case study in that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one that window 2 went to window 3 and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
Houston, go for the vehicle system update.
Howdy, Reid. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. and you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window, and just what I'm going to call the Mare around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour, looking up close. I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on those solar arrays so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reid.
Affirmative.
Some good words there between Capcom Jenny Gibbons, one of the two backup crew members for Artemis 2, exchanging words with Mission Commander Reid Wiseman, giving some good descriptions of his experience for the past about hour or so as they've been, he and Mission Specialist Jeremy Hansen have been the ones behind the lens at the window, capturing all of the imagery that has been described in part by Victor Glover, the mission pilot, and Christina Koch, one of the two mission specialists. Now, as you heard, they are conducting a crew swap, so where Reid and Jeremy have been going back and forth between taking images and making contemporaneous notes in an audio format so that all of the fully rich and exact science observational data is recorded as it's being observed. The now two free crew members, Reid Wiseman and Jeremy Hansen, now in the spots that Victor and Christina were previously at, will now be relaying what they're overhearing to Dr. Kelsey Young, who is the science lead. She will be the other voice that is currently in the white flight control room at the Johnson Space Center, communicating with the crew on board the Orion spacecraft. If you're just joining us, we're approaching the top of the hour here. It's almost 3 p.m. Central Time, approaching 4 p.m. Eastern, 2000 UTC. If you're just joining us, welcome in. You're watching Spaceflight Now's live dedicated coverage of the lunar flyby of the Artemis 2 mission. As you can see in the upper right-hand corner of the screen, we are currently, I'll call it F- 3 hours, 7 minutes, 2 seconds and counting, as the point at which the astronauts on board Orion will be at the very closest to the moon, about 4,000 statute miles above the lunar surface. And you can see in the graphical data here in the bottom right what they're looking at right now. They're just crossing 8,230 miles to the surface of the moon. For those who are just dipping into the Artemis 2 mission, this is not setting up for a lunar landing, nor are they, like in the Apollo 8 mission, going to be entering into the moon's orbit. The speed at which they're flying by the moon, which you can see is currently 1,031 miles per hour, will continue to pick up as the Orion spacecraft makes its approach to the moon, but then they'll be experiencing a slingshot around the moon and then begin to make their journey back to Earth. As you can see, they're more than 250,720 miles from the Earth. Earlier today, they crossed an important milestone for historical record, becoming the humans that have traveled farther than anyone else in human history. One of the communications that we heard from Capcom Jenny Gibbons up to the Orion crew making their science observations as they're in this swap handover period where they will take out the SD cards currently in the cameras that were being used by Reid and Jeremy, and they'll put in the SD cards from Christina and Victor. All of the crew have been assigned specific SD cards for this mission and will do their level best to make sure that those don't get mixed up, but the serial numbers have been understood from the ground to Orion, so hopefully it all stays straight and everyone will get the proper photo credit that they are due once these photos are downlinked back to Earth. There was a reference by Jenny Gibbons about the toilet currently being no-go right now. They need to conduct a flushing operation, sending the waste material out of the Orion spacecraft, which will happen likely sometime after the formal lunar observation period ends later on tonight. In the meantime, if the Artemis 2 astronauts do need to use the facilities, if you will, they have what are called the Collapsible Contingency Urinal, or the CCU. NASA astronaut Don Pettit gave a good description, and if you're on X, I highly recommend you head over to his X account and you can see good photos of what the CCUs are like. He describes them as, quote, an open container, reusable, sealable, and drainable, that controls the urine-air interface using capillary forces like my Space Cup does for coffee. Don Pettit created and patented a really unique design for coffee cups that astronauts on board the International Space Station have been using for years now at this point, allowing them to enjoy a fresh cup of joe. You just don't want to get those two mixed up, of course. But the CCU is considerably longer than the coffee cup, so that hopefully won't be an issue. As he says in his post, and I'll quote him here and give him the comedy credit he deserves, quote, when you're in cislunar space with a broken toilet, you need contingencies.
Houston, the professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation posts and looking in. It's super fun.
Copy all, Reid. We like it.
Just to quickly close the loop on the comment from Don Pettit. When you're in cislunar space with a broken toilet, you need contingencies, and the CCU replaces the need for about 25 pounds of diapers, end quote. Don Pettit, good behind the camera, and quite a witty astronaut as well. Currently now 3 p.m. here Central Time, 4 p.m. Eastern, 2000 UTC, as we're currently looking at about 3 hours, 1 minute, and just under 30 seconds remaining till the closest approach of the Orion spacecraft closest approach to the moon by the Orion spacecraft that the crew named Integrity. As you can see with the telemetry data in the bottom right-hand corner of the screen, we are approaching 8,000 statute miles between the surface of the moon and the Orion spacecraft. The closest that they will come is about 4,000 statute miles.
And Jenny, for the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data, Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reid. We're taking note, and we'd be curious too.
Integrity Science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert is kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimati is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Grimati. And then south of Grimati, Jeremy and I were noting a few other just really dark areas of cratering, or I'm sorry, mare there, and those have that same darker albedo, but Burgess Alpha is the brightest, and Grimati is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Grimati, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reid, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the SIR was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
You've been listening to communications between Artemis 2 Commander Reid Wiseman on the Orion spacecraft and the woman that you're seeing there stand in the box in the upper left-hand corner of your screen with the dark jacket. That is Dr. Kelsey Young, the Artemis 2 lunar science lead. The reference to the SIR, as we just heard, that is an acronym, stands for the Science Evaluation Room. As the observations from the crew members of Artemis 2 are coming down verbally, they're being evaluated, and the team and the SIR are also making their own observations based on what is seen and what has been predicted will be seen as the trajectory brings the Artemis 2 crew continuously to begin their flyby around the moon. Currently, as you can see in the bottom right-hand corner of your screen, the astronauts are about a little more than 7,400 statute miles above the moon's surface, traveling at a velocity of a little more than 1,000 miles per hour. The clock in the upper right-hand corner of the screen will continue to tick down as they are making their closest approach to the moon, which will be roughly 4,000 statute miles above the lunar surface. This graphic in the big part of the screen has a ticking list on the far left-hand side. The items in blue, well, if it comes back up, I'll make reference to it again, but not overly confused, folks. I'll wait till it returns before I make reference to it. Also, during the various observation comments that are coming down from the crew, you may hear passing references to something being Vaviov away from another lunar feature. Vaviov is a crater that is on the far side of the moon. The reason, most likely, it's been selected as a reference point for the Artemis 2 astronauts is it's about 99 kilometers wide, so it's a good auditory description for the astronauts to make a quick reference point back to the science team on the ground to say, hey, I'm looking at this feature. It's about, 1 Vaviov or, 1.5 Vaviovs away from this other feature. And then the scientists on the ground can get a good bearing of what the crew is seeing for themselves with their own eyes, making sure that everyone has a common understanding and are speaking quite literally the same language when being able to translate these in-the-moment observations down to usable science and get the context that's needed for future cataloging. As our coverage continues on the lunar flyby and science observation for the Artemis 2 mission, want to give a big thank you to the 8,100 of you who are watching along with us live today in this piece of Artemis history, and really human history. If you'd like to support what we're doing here in our on-the-ground reporting in Houston, a great and quick and easy free way to do it is just by clicking that like button beneath this live stream, and make sure you're subscribed to Spaceflight now. Also, if you'd like to learn more about how the crew prepared for this moment, we've uploaded a great video on that here to the YouTube channel. So if you're watching this on your laptop, you can open up a separate tab and have the commentary going from the lunar flyby, and you can watch this video that we just uploaded earlier today about how the crew prepared for it in talking with one of the lead visual trainers from a company called KBR that was a contractor working with NASA to train the crew. That video also contains some insight from two of the crew members who we've been listening to throughout the course of this lunar observation period. Pilot Victor Glover and mission specialist Christina Koch. You'll also hear directly from Dr. Kelsey Young, her thoughts and hopes for this flyby period that is currently underway. Again, for folks that are watching this in real time and not catching this on a replay, we'll go ahead and put a link to that video for you in the live chat for your convenience. I want to thank our moderators as we're waiting for further science updates. Thanks to Jeff Hansen and Astro Joe for helping us out today in the live chat. As a quick reminder on the chat rules, that will be of great help to our mods and a help to you if you don't want your message to get the sensor hammer brought down. We ask that you please be kind enough to post your message in English so that our moderators can respond as appropriate. There are plenty of other forums for conversations about religion and politics, but this is not one of them, so we kindly ask that you respect that. Also, please don't post your message in all caps. Emojis are perfectly fine. We just ask that you don't create a huge block of like several lines of them so it takes up a large visual chunk of the live chat. And last but certainly not least, we ask that you treat each other with the kindness and respect that you yourself would like to be treated. Also on tap for today, sorry, just conferring off mic about the timing and schedule of things today. It's there are a lot of balls in the air when it comes to covering spaceflight these days. We just want to make sure we're bringing you accurate information. Coming up later tonight, SpaceX will attempt once again to launch its Falcon 9 rocket from Vandenberg Space Force Base after they had to scrub the mission yesterday due to high winds near the pad. So they will try once again tonight to launch the Starlink 17-35 mission, a batch of 25 Starlink V2 mini optimized satellites into low Earth orbit. Our live coverage on that will pick up about an hour, a little less than an hour after we wrap up our dedicated coverage on the lunar flyby, I think is the current plan. Some of the next big milestones on the timeline, not the more fine details of the specific observation targets, but some of the big fly-by-day events in general. Again, we're currently at about 4:30 p.m. Eastern Time, so in a little bit more than 2 hours from now, at 6:44, that's when the crew will start to slip behind the moon from the perspective of us here on Earth. That will begin about a 40-minute comms blackout period, or communications blackout. That is predicted because we don't have a lunar communications relay around the moon for now. The crew will be in a point where they will not be able to hear the astronauts for, again, about 40 minutes. Then at 7:02, in the midst of that blackout period, the crew will make their closest approach to the moon. That is what is the countdown clock. That's what the countdown clock in the upper right-hand corner is representing right now. At 7:07 p.m., the Artemis 2 crew will reach their maximum distance from the Earth. And at 7:25, again, all these are in Eastern Time, the acquisition of signal will commence with the Orion spacecraft. Following that, a little more than an hour later, at roughly 8:35 p.m., the Orion spacecraft will enter into a period of a solar eclipse. So the sun will slip behind the moon from the perspective of the Orion spacecraft. And that eclipse period lasts the better part of an hour. Wrapping up at about 9:32 p.m. Eastern. So it's a jam-packed day for the Orion inhabitants. And we'll be following it along with you every step of the way. So we certainly appreciate you for dipping in here with our coverage.
Time for a window team position swap. So Victor and Christina, please switch places if you've not done so already. And remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change cards in the long lens.
Copy.
As the crew swap takes place, they'll do this periodically throughout the course of the period of lunar observation here today. Just about 2.5 hours remaining before the closest approach of Orion to the lunar surface. Again, they'll come within about 4,000 statute miles above the moon. For those just dipping into the world of Artemis 2 coverage, just want to remind folks that the Orion spacecraft will not be entering into lunar orbit. Reason for that is essentially twofold. The spacecraft will be traveling too fast for the moon and its gravitational pull to bring it into its lunar orbit, but it will help bend the trajectory of the Orion spacecraft, which is how they plan this mission architecture. So the Orion spacecraft will essentially slingshot around the moon, as you can see in the graphic in the bottom left-hand corner of the screen. You can see where the moon is and where Orion is. Kind of a funky figure 8 here. But the gray line is the orbital path of the moon around the Earth, which you can see sort of in the midst of the blue trajectory line here. And so from this graphical perspective, you'll see the moon just pass on by because it's continuing on its orbit. It is oblivious to the presence of Orion, but Orion will be affected, as it continues to be, by the moon's gravitational pull, perform that slingshot trajectory around the moon, and then begin their journey back to Earth. Let's hit splashdown off the coast of San Diego, coming up on Friday, April 10th. We certainly appreciate our global audience who is joining us today. We've got more than 8,400 of you watching along with us live per the numbers on YouTube. A lot of folks, a lot of our family and friends also watching along with our coverage as we're continuing to watch the progress of Orion. Want to give a special shout out to all the high schoolers over at Intercom High School in California. And a special shout out to Mr. O.
Houston Integrity, you ready for a science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice element. I've been listening to both of them for a little bit, and they're really enjoying, they both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like
I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view. And now we have a lot of the dark side of the moon that, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness. And my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that on the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Oriental, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
Definitely not looking to interrupt your flow, Reid and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying. Okay. Not really science related, and we definitely learned this at Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as
as rugged as the far side looks. When you look at Oriental and Home, it's rugged. But man, when you look at the Terminator, it is just like impossibly rugged. And it reminds you that the whole far side is that way. And just the Terminator is really bringing out the shadows and the hills and the valleys. And it is just, it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact. And it's just, it is very impressive to look at that. And you realize that that is true across the whole far side. You just can't see it due to sun illumination right now.
Reid, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you.
As Dr. Young is looking for that crater reference for the crew on board Orion, just want to make a quick bit of context here. You heard them mention rays on the moon a few times today. Rays are essentially when a meteor impacts the moon, it creates obviously the crater, but when it does create that crater, there's big pieces of regolith that get ejected and shot out in multiple directions away from crater, and as that material settles back down onto the surface of the moon, it becomes a slightly lighter color, and so you can see some of those distinctions when you look at certain regions of the moon. Like if you look at the Tycho crater, for example, which according to the Lafayette Science Museum is best able to be spotted about 3 days before and 3 days after a full moon. For us here on Earth, it's located in the southern hemisphere of the near side of the moon.
We're loving that picture. Thanks for showing us. And Reid, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
Local time here is 3:54 p.m. Central, 4:54 p.m. Eastern, 20:54 UTC for those joining around the world. You heard a reference to an iPhone photo that one of the crew members was able to capture. I believe that was Reid Wiseman. This mission, Artemis 2, is...
Integrity Houston, it is time for another swap between the cabin and the window teams. So we have 15 minutes of handover time, and then we will expect Jeremy and Reid at the windows and Christina and Victor at the cabin. I have no new vehicle updates for you, but I do have a photo location for some photos on Ike's PCD, and I want to let you know that Jeremy's family have arrived in the viewing gallery.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD. And hello to my family. I think that must be Catherine and Devin that are there. And I'm glad they made it into the viewing room. And we copy it's time for crew swap. The A team's coming out of the windows and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Some words exchanged between Capcom Jenny Gibbons, one of the backup astronauts for the Artemis 2 mission.
Okay, copy, Jenny. We're not sure what we're looking for in the PCD, but we're going to poke around, and we may be calling you back about that one.
All right, that's no problem, and it's unrelated to flyby.
Jenny Gibbons, like Jeremy Hansen on board Orion, a Canadian Space Agency astronaut. Gibbons currently serving in the Capcom position alongside NASA astronaut Stan Love. There was a reference just a little bit ago to an iPhone photo captured by, I believe it was NASA astronaut and commander Reid Wiseman for the Artemis 2 mission. I want to go ahead and show that to you. The Artemis 2 flight, the first time that iPhones have made it onto a deep space mission or going up to space in this capacity. And you can see that photo there as the background or in full frame on the iPhone. Going to go out on a limb and say this very well will probably become Reid Wiseman's screensaver background, becoming one of the first people, if not the first person on this mission to capture a lunar background from the lunar sphere of influence and have it be right there on their iPhone. Just incredible. And as you can see, when the phone moved away from the interior cabin, it is extremely dark inside the Orion spacecraft, and that is, of course, to allow the astronauts to have the best possible opportunity for photography on this mission.
Houston a little preview of what's to come, but something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45 minutes we'll have 2 identical crescents as we change our position in the universe.
That is pretty darn cool. Thank you.
Time now currently just past the top of the hour, 4:04 p.m. Central, 4:05 p.m. Central, 5:05 p.m. Eastern, 21:05 UTC for those joining around the world. As you can see, we are also less than 2 hours until the Orion spacecraft makes its closest approach to the moon. Currently just a little more than 6,000 miles above the lunar surface. It will reach an approximate closest approach of about 4,000 statute miles. You may have also noticed that the velocity of the Orion spacecraft has dipped a little bit below the last time we talked, where it was above 1,000 miles per hour. This is to be expected and is part of the trajectory plan as the Orion spacecraft makes its closest approach to the moon. It will start to pick up speed as it comes around the moon and is in a slingshot back towards Earth. We sort of think about as you're driving down a highway, how you have to slow down as you come into the curve and you speed up heading out from it. Generally speaking, the same principle applies with a spaceship. But in the words of one Dr. Emmett Brown, where we're going, we don't need roads. Seeing a good bit of talk in our live chat about what exactly we're seeing at various points. Right now up on the screen is a live view from one of the cameras at the tip of the solar arrays, one of the 4 solar arrays on the European service module for Orion. This is a live view of both the spacecraft and the moon. If we go back to one of the visualizations here. Time to closest approach, 1 hour, 53 minutes, 33 seconds and counting. You can see if you look just underneath that clock that is counting down to the closest approach, the crescent Earth that we heard Reid Wiseman describe in this visualization of the Orion spacecraft. That's to the right. To the left, of course, is the moon itself in gibbous. Coming up in less than 2 hours, Orion will slip behind the moon from the perspective of the Earth. And where the Terminator is still in position in relation to Orion, if we go back to the onboard camera view, you can see it's about still a little less than half of the moon is shrouded in darkness, but that will continue to evolve as the crew moves behind or continues to go behind the far side of the moon and will be lost behind or from the position of the Earth, and it will become more of a crescent shape from the Artemis II crew perspective. So yes, in the course of our live coverage of the Artemis II flyby, we are seeing a combination of both live real pictures from the Orion spacecraft, which is what is up on the screen right now. If I go to this graphic here, for example, this is a visualization, another word for a virtual representation of where the Orion spacecraft is in space in relation to both the moon and the Earth. It's a digital way to get a sort of a third-party perspective orientation on the moon. If you want to think of this more of in like video game terms, this is more of a third player type of perspective. as opposed to the onboard camera view will be our first-person player perspective. A little bit over the shoulder as opposed to seeing right exactly what they're seeing, but you get my drift.
Houston integrity for SITREP. First of all, I'll just talk about the experience that I had during Victor and my observation time. It was an incredible experience. We definitely noted how much more you can see with the zoom lens. Even though we have a great visible eye image, there's just a lot of texture that just pops right out at you when you can zoom in. So almost just using it like a telescope, the camera lens. We really enjoyed our discussion time. That was a great innovation on the lunar targeting plan. We were both able to describe a lot more kind of with flow, I would say, when we were talking to each other. And it was also, we sort of were able to bounce ideas off of each other and come to new conclusions. We had, I think, a very successful talking through of some contacts between different color areas, both in the mare and in the highlands, and we identified some really unique texture areas as well. At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they are still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear. Other than that, everything's working well technically, and we've been able to find all our targets, and we're having a really great time.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description. Integrity cabin team for window shroud.
We're listening. Go ahead, Jenny.
Hey, Victor, we have a temperature constraint on the windows, and the shroud might be getting us close. So we just want to check on the state of window 4's shroud, whether you believe it's still necessary because maybe things have changed with our viewing. And if so, we would like to request to have the shroud removed.
Houston, we believe it is necessary. We pulled it off just as a corner. It is very bright. It definitely would affect our night vision and maybe comfort. But is there a time? Can you tell us when we would have to take it off by?
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Okay, we're removing the shroud, and we will we'll make it work. Thanks.
Thank you, Victor. We know it's pretty bright in there now with that window uncovered. We will also offer that airflow on the window would be helpful. So if you want, you can also retrieve the condensation hose, which should be friction fit onto one of the diffusers. And that on the window would also help.
We can easily point a diffuser at the window, so we're going to start with that. And it's pointing at the window now.
Okay, we'll take that, Victor. Thank you. Please keep us updated.
Local time here in Houston, 4:20 p.m. Central, 5:20 p.m. Eastern, 21:20 UTC for those joining around the world. We're about an hour, 41 and a half minutes away from the closest approach of Orion to the moon. And as you've been hearing, they put a bit of, it's been referred to as a shroud, covering on the fourth window that has been the one closest facing towards the Earth and has been allowing quite a bit of light to come in previous to the shroud going up, and so the crew put that up there in order to make Orion as dark as possible which aids in the lunar photography.
Science, integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan. Reid just passed me a note that the Oriental Basin annular ring has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it.
Victor, thank you. You got a cheer from science there, and we all just went on that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have Deanna Glover with us in the viewing gallery. She's all smiles.
Well, you just got a bunch of cheers up here. Hey, babe. I love you from the moon.
We love that we got a hey babe too, and we also have one of your lovely daughters here watching you guys work.
Thank you guys for doing that and for supporting them through this. And to all of you, Genesis, Maya, Joya, and Corinne, I love you. And Deanna, I love you. I'm glad you get to be there.
As we've heard throughout the course of the lunar observation period, some of the family members of the astronauts have been making their way into the gallery alongside the white flight control room, or the white Vicar. Most recent addition, as we just heard, Deanna Glover, the wife of Artemis II pilot Victor Glover. Possibly the first communications from deep space of, hey babe, back to Earth as well. And nice that one of Victor's 4 daughters could also be there with their mom. Of course, this is a scientific mission of lunar observation, but as we've been hearing the descriptions from Victor Glover and from Christina Koch and previously Jeremy Hansen and Reid Wiseman, this is also a very human mission. There are just intangibles that come when you put a human in the loop on something like this that is so distinct from the experience that was had by the Apollo astronaut, and so vital to have the type of imaging in the hands of these storytellers that are currently making their way around the moon, that you can see images that are captured by the Lunar Reconnaissance Orbiter or by other future robotic spacecraft, but there's just something about how humans can discern color and create a frame of reference for these different features on the moon that is just irreplaceable by cold technology. And so having these astronauts who were very thoughtfully and intentionally selected before they were announced back in the spring of 2023, well, we're seeing that selection decision paying dividends here today on this, one of the most crucial days of the Artemis II mission, as they've been trained thoroughly in how to identify these various pieces of geology here on the moon and convey what we just heard from Victor, the sense of what the moon evokes in the human spirit. Just remarkable.
Science from integrity. Let me find out how far we are from the moon right now. But our view is about a third of the moon is in eclipse. That beautiful Terminator is out there calling to me. We're 4,691 miles from the moon. And what looked like in the Terminator about a third of the way up from the southernmost part of the Terminator looked like a dinosaur print. If one was running to the northwest, now is clearly a crater with a bunch of craters around it. And that Terminator, I can only see about half of it. I'm looking through the docking hatch window right now because we have the Z9 in window 1. But that Terminator has moved. I guess I've been using Vavilov the whole time, so it's gone 2 more Vavilov craters to the west. And so a few more features are starting to peek out into the sunlight there with that low sun angle. And so you still have ridges and valleys showing up very clearly, a very jagged Terminator, and a few islands of light out there with some high elevation shining in the sunlight in that darkness. And on the eastern side of the moon, Grimaldi appears to be one of the farthest east features, and that is maybe 5 degrees from being right on the limb and going off over the horizon. It is interesting, just looking at Oriental, that my first impression of it is all of the dark areas appear lighter, which I think makes sense because it is now facing, well, it's still relatively the same to the sun, but my angle to it is different. So I'm looking at it from a little more, even further to the side as we pass it. But all the darker features appear to be just a little bit lighter from this vantage point. The darker ring structure in the outer and inner ring and the interior, as well as the annular ring portion, everything seems to be just a smidge lighter at this point.
Thanks for that description, Ike. Any additional words you can provide on Oriental would be wonderful, as that is such a high priority target for us. And while I have you, as we get closer to target 15, which is the Terminator target, if you can find Zeeman crater again that you were looking at earlier, everything to your left of Zeeman would be getting into the South Pole Aiken area to help you orient yourself.
Zeeman is a great waypoint out there. I definitely see it. Yeah, Zeeman is very easy to find, and that is awesome. Thank you for pointing that out. Feel free to do that as often as you think of things. Let's see, looking back at Oriental. Okay, another thing, after looking through the zoom camera, man, you guys are smart. You probably did this on purpose, but after looking with my plain eyes and then going to the 400 millimeter zoom, now looking at it, I see the cliff face as if you were standing in the center. That inner and outer ring have definitely some real terrain to them, and now I can see that as terrain. Now that I look at it even with my naked eye, I can tell that there's a lot of elevation and that, like I said, a cliff face on that eastern edge where all the darker deposits are. And it's just the scale now. Looking at it from far away before, it seemed like flat with color painted on it, but now that I look at it, I can definitely see that there is, different depositional characteristics, and so the darker is some other material, but there's also some shadowing going on because of the cliff face that is a part of that crater wall.
Great description, Victor. Thanks, and really interesting to hear now the distinction between shadow and color. Before I let you go back to other observations, you mentioned that Reid saw a browner hue to the annular ring than the rest of Oriental. Are you seeing that from your vantage point?
The way that I'm looking at Oriental, again, I'm still in the docking hatch window. There's like a thermocouple right here in the center of the window, and it is the orange Kapton tape color, and so it is unfortunately, it's like trying to look at stars, next to a metropolis. I think it's drowning out any color that I could pick up from the moon. I am not able to see that color, but I have not looked at it through one of the forward face, from one of the windows 1 through 4. I think when I get away from this Kapton tape strip that I would be able to see the variation that Reid's talking about.
That is great feedback operationally. Thanks, Victor. I'll leave you to it.
Science integrity with a question from the window team.
Integrity, this is Science here with you.
Yes, they have a question to help inform a theory that they're sort of tossing back and forth. What is older, the Mare seas of the near side or Oriental?
Stand by, Integrity. We're going to get you a little geologic history here. Integrity Science back with you for some lunar volcanism when you're ready.
Go ahead.
You're making our day down here getting to talk about lunar volcanoes. Oriental, as far as mare go, is younger than almost all of the mare on the near side. The exception are features like Aristarchus, which really pop out to you guys and really pop out to us here on Earth. That is younger, but other than that, Oriental is pretty young as far as mare go.
And Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you, maybe you've heard the window team talk about the sort of contacts around Oriental, but because that material is so much younger, if anything pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the basin and understanding the superposition of its ejecta and mare on the near side or other features. So thank you. We'll take the insight when you have it.
Thank you, Integrity. And I know Jenny wants to get to you with some topics, so I'll leave you with Oriental is 3.8 billion years old.
Copy that. So that's on the older side. The actual basin is very old.
Correct, as is the case with a lot of mare. Typically the big basin formed, and then the volcanic eruption was able to punch through the crust where it was weakened by that basin formation.
Perfect. Tracking. Thank you.
Better answer.
Integrity, it's about time for a position swap at the window. So we will ask Reid and Jeremy to swap positions, and I'll remind you again about your SD cards. And Victor or Christina, I have one window task for the cabin team when you're ready.
They are swapping, and I'm ready.
All right, Tina, we found a way that we can reinstall the shroud on the window. We understand it's pretty darn bright compared to everything that you're looking at. So in order to reinstall it, we will ask that you retrieve the condensation hose and you install it on a friction fit on the cabin air outlet port. That's right by one of your diffusers. You're going to point that little condensation hose such that the air is flowing over the window pane. Let me know when you're ready for the stowage location.
Ready.
Christina, the hose is in locker A1.
Copy.
Getting a glimpse inside the Orion crew module here as you just heard communications from Capcom Jenny Gibbons up with the crew of the Orion spacecraft. The window swap that was just being described as a change of position between Commander Reid Wiseman and Mission Specialist Jeremy Hansen, who are currently at windows 2 and 3 right now on the Orion vehicle. The way that NASA decided to set up the observation period is they'll have one astronaut who is pointing a camera out the window and taking observations both with their eyes and then through whichever camera that they have at that particular moment in time. And then adjacent to them, sitting in the adjacent seat, will be the other buddy, if you will, in this duo setup, who is there to take detailed observational notes on their tablet, as well as to help with the recording for whichever crew member is actively taking the observation, just to make sure that the most thorough contemporaneous notes are captured in this critical moment of flyby that has been built up for years now. The planning for this mission goes back to before the flight of Artemis 1 to 2021, and even a little bit earlier than that as well. As you're taking a look at the telemetry data in the bottom right-hand corner of your screen, you can see the Orion spacecraft is a little bit more than 5,000 miles above the surface of the moon, closing in on the final hour before it makes its point of closest approach today. You can see that countdown in the upper right-hand corner of the screen, and kudos to John Pisani for getting that one worked out. Orion spacecraft traveling at a velocity of 968 miles per hour at this particular moment in time. Again, as we're seeing the vehicle creep up to the 5,000 statute mile point above the lunar surface. It will be about 1,000 miles less than that by the time we see the spacecraft reach its closest approach. And I say see, generally speaking, by the time it makes its closest approach, it will be behind the moon from the perspective of us here on Earth. And so the comms blackout, again, is expected to start roughly at 6:44 p.m. Eastern, 5:44 p.m. Central, 21:44 UTC for our friends joining around the world. As we're getting closer to that point of comms blackout, we don't want to leave you left in the lurch, so we'll be joined by a special guest coming up here in about 45 minutes time.
Houston integrity question, did you just want us to cool the window with the condensation hose, or did you want us to put the shroud back on and cool the window at the same time?
Victor, we definitely want you to cool down the window with the condensation hose. It's crew preference whether you put the shroud back on. The hose will allow you to do that if it helps with your lunar flyby.
Okay, copy. We're going to do both at the same time. Thank you.
Houston copies.
Houston, thank you for that suggestion. The cabin is darkened again, and that makes a big difference for the imagery. And for science, we are now seeing a half moon.
Thank you, Victor. We're happy to hear it. And we see half moon, full moon joy still.
And as the crew passes the point where, as we just heard from pilot Victor Glover, they are seeing a half moon. We, like the folks in Mission Control Center in Houston, are full of moon joy that you are able to be with us live as we are watching this historic Artemis 2 flyby. The first humans to see many of these far side features, as the lighting on the lunar surface is decidedly different than it was during the Apollo missions in the late 60s and early 70s, where those crews, their mission planners made a point to focus on launching during a period where there was the most illumination on the near side of the moon. The Artemis 2 crew have the benefit of this not being a landing mission, which means that given when they launch, they have about 20% illumination on the lunar far side.
In science integrity, another observation the window team commented on and Christina and I discussed a bit is in Hertzsprung. The solid and intact crater is very smooth. If it were a dirt road, it's very hard packed, and then you go outside of it, and that outer crater, that's the one that is older, it is a little rougher and more jagged and starts to get into more loose-looking terrain. And the smooth interior also causes the craters that are inside of the larger crater, the smaller craters, to have really sharp edges, sharp, distinct edges. And just a general comment on that area, Hertzsprung, that whole area, the average albedo there is darker. That is, I would say, 3. And the average albedo around Oriental and between Oriental and Ohm, excluding the wedge, the darker wedge, is more on the 6-7. And that they also seem to be different texturally. Christina described it earlier around Hertzsprung, and then from Hertzsprung toward toward Oriental, there appears to be a frozen, a rippling pond, but frozen, or like choppy waves when it's windy out, choppy water, and then it freezes instantly. That's the texture. If you walk down there barefoot, it looks like it would be hard on your feet, like lava. After it's cooled, it would be pokey. Except for right there in the center of Hertzsprung, it looks paved, like a paved road, nice and smooth.
Victor, that's a wonderful description. Going from a paved road to lava reminds us of the Icelandic highlands. Thanks for that.
In science, another in the interior of the very intact, the interior of the intact crater at Hertzsprung is albedo variation. I think I heard one of the window crew maybe say color variation, but definitely albedo variation. There's lighter patches and slightly darker patches. It's not swirling, it's just patchy. It just has spots that are lighter, and I would say a predominantly darker average area.
Great descriptions, Victor. Thanks. Not swirly, just patchy is really helpful for us.
In science, the window team is hitting all the targets. They are on plan and starting the discussion of the Terminator. And boy, I'm loving the Terminator. I think I know it's not purely a moon feature, but what it does to the features of the moon, to the terrain, I've probably spent the most time describing into my recordings and thinking about and looking at the Terminator. There's just so much magic in the Terminator. The islands of light, the valleys, what look like black holes. You'd fall straight to the center of the moon if you stepped in some of those. It's just so visually captivating that the Terminator is the most striking thing that I've seen so far.
We've been loving your evocative descriptions, Victor. You really are bringing us along with you, and we're following along with visualizations that pale in comparison to your descriptions. Thanks. Integrity Science, one more question on a status of what the window team chose to observe for crew choice.
Window 2 talked about Vavilov, looked for suspended dust, and the Terminator. And window 3 about the experience and about the three-dimensionality of the moon this close.
Wonderful.
And
Thanks,
another
Victor.
observation about Oriental, I would say, is the features going off to the southwest, the two large, almost look like scratches in the surface. I don't know if they're rays or canyons or collapsed lava tubes, but two distinct features that are almost parallel going off southwest from Oriental Basin. They are the first things that made me notice parallax of our trajectory looking out at Oriental. That and in the inner walls of the east side of the crater rings, you really get a sense that we're flying over something with elevation and terrain, and they look different from this orientation.
Love to hear it, Victor. And you had it that those chains are actually crater rays, secondary craters formed from the formation of Oriental.
Yeah, speaking of crater rays, the crater rays that are going off to the northwest, that run off toward Hertzsprung and I believe toward Vavilov. I'm not looking out at it right now, but those crater rays are very interesting. They're all very small. I know you've imaged this, but they're all small, and they look like, you know, a big impact launched rocks and things that made smaller impacts down the way. But something very interesting, and again, you can see this in imagery, but some of them are parallel, and then some of them converge toward the center of Oriental. And then I think I even saw some that maybe diverge, which not diverge, but that are convergent, which indicate multiple large impacts that created a lot of secondary impact crater rays.
Fantastic, Victor. And I'll note that we can infer that you're looking down at your freshly named Integrity crater, which is near the end of one of those beautiful crater rays from Oriental. Thanks for the description.
Yeah, you're welcome. And Integrity is easily identifiable with the naked eye from this point.
Orion is now less than 1 hour away from making its closest approach to the moon. If you're just joining us here, you're watching Spaceflight Now's live coverage of the Artemis 2 lunar flyby, a multi-hour long slingshot around the moon where the crew has been getting and relaying fantastic science observations about the lunar surface below to the science team at the Johnson Space Center in Houston, Texas. Right now at the window of the Orion spacecraft, or to be more specific, at windows 2 and 3 on the Orion spacecraft, as you can see the science team taking a photo collectively, pausing from the rigor of the mission for a moment to capture this piece of history.
Integrity Houston, we are ready for our cabin and window teams to swap again. We have a 15-minute handover time here, and I have a couple of items I want to read up to you. They'll require you to write something down on your knee boards, so let me know when you're ready.
Okay, Houston, we are ready.
Copy Integrity. First of all, once you start this next shift here, during this lunar observation shift, we will begin our lunar LOS, so you can expect a call from me a few minutes prior reminding you. And second of all, FIDO just sent us updated altitudes and METs for lunar closest approach and max Earth altitude. Let me know when you are ready to write those down. They differ slightly from Optimus.
Thanks, Jenny. We are ready to copy.
Lunar closest approach will be at MET 5 days, 0 hours, 25 minutes, 34 seconds. And the altitude will be 4,067 statute miles. Maximum Earth altitude will be at MET 5 days, 0 hours, 27 minutes, 39 seconds, with an altitude of 252,756 statute miles.
The crew really wants to ask for that in kilometers and in parsecs, but thank you for those. That is great. Thanks for that update.
I'll send FIDO to work, and I appreciate the metric. Other than that, I have no new vehicle statuses to pass to you. Enjoy your handover time, and we're looking forward to picking back up with you shortly.
All right, we'll talk to you shortly.
And as you just heard, we've got a bit of refinement here as the Orion spacecraft is within an hour of reaching its destination, if you will, of the closest approach to the moon, which will happen during the communications blackout period. You're looking live inside the Orion crew module capsule there. Again, this is a very dark image right now with just a smattering of light because they want to keep this environment as dark as possible in order to allow for the best possible imagery to be taken. Per the Capcom on this current shift, Jenny Gibbons, a backup astronaut from the Canadian Space Agency for the Artemis 2 mission, the closest approach to the moon for the Orion spacecraft will happen at mission elapsed time 5 days, 0 hours, 25 minutes, and 34 seconds, at which point the Orion spacecraft will be 4,067 statute miles above the surface. Meanwhile, a little bit further in time and in relation to our planet here, they will be officially the furthest from the Earth at mission elapsed time 5 days, 0 hours, 27 minutes, and 39 seconds. Put another way, the closest approach is set to happen at 7 p.m. and 46 seconds Eastern, 6 p.m. and 46 seconds Central. That's 2346 UTC for those joining around the world.
Houston Integrity, if you got a moment.
Go ahead.
I don't know if Catherine and Devin are still there, but if they are, just wanted to just let them know how much fun we're having out here. It's extraordinary to be on the far side of the moon right now, just hanging out there and looking back at the Earth. And Ashley and Caitlin, I know you're back in Canada, but if you happen to be watching too, just wanted to say hi to all you guys. Love you guys, and we'll be heading back your way shortly.
Thanks, Jeremy. I hear they are watching, and your family is still here. So thanks for passing that along.
Local time here, 5:14 p.m. Central, 6:14 p.m. Eastern, 22:14 UTC for all those joining around the world. You're looking live at a few different vantage points on the Artemis 2 mission. In the big box is a view looking inside the Orion spacecraft as see, Commander Reid Wiseman is in the foreground here, making some observations, having a little bit of a snack, as the crew has been working diligently and they're approaching their midday meal in relation to when they woke up at around, let's see, that was 9:50 a.m. Central Time. Moving between visualization elements like what we're seeing here on the screen and real-time live stream camera views from the Orion spacecraft are getting a good variety of vantage points on the Artemis 2 mission as the closest approach to the moon draws ever closer. Time now 5:19 p.m. Central, 6:19 Eastern, 22:19 UTC. We are currently flyby closest approach 41 minutes, 25 seconds and counting. For those wanting to just look at a clock and see where we're at as opposed to the countdown timeline, it's going to come up the closest approach to the moon at 7 p.m. and 46 seconds. That's p.m. Eastern. And the Orion spacecraft will be the furthest from Earth at 7:02 p.m. Eastern and 51 seconds. Live view now back inside the cabin of the Orion spacecraft. Some varying views of how bright it is inside here. Just taking a look inside the Orion spacecraft that's now just head out of the top of the frame. Commander Reid Wiseman. Earlier, the astronaut who we saw taking a bite was actually Jeremy Hansen. It was a little hard to see on my screen here with the lighting inside the Orion at the point in time it was new. Victor and Christina were in the windows, but it was a little bit tricky to see who was reaching for the bite of food back about 10 or so minutes ago. As you can see, Christina is currently in the observation mode, taking pictures with one of the Nikon cameras. Pilot Victor Glover doing the same. You can see him just tucking up one of those Nikons down around his knees as he's sitting in seat number 2. Christina in seat 1. A little more than half an hour away from when the Orion spacecraft will make its closest approach. A good roundabout view of the various vantage points here on the mission. Outside of the Orion, from one of the solar panel wing cameras in the top left, moving around clockwise, you got the interior view of Orion upper right. Below that, a visualization of the Orion spacecraft with some telemetry data, and then a look at the science desk there in the white flight control room, or the white FICR here at the Johnson Space Center. And as you can see with the clock in the upper right-hand corner of the screen, we are now less than 30 minutes away from the point at which the Artemis II astronauts on board their Orion Integrity spacecraft will make their closest approach to the moon.
Integrity Houston, 10 minutes till the LOS. We'll take a snappy sit rep from the cabin if you have one.
Okay, Jenny, that came, we missed most of that, but just a 10-minute warning, is that what you're saying?
10-minute warning for the LOS, and I'll take a quick sit rep from the cabin, please.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reid's actually been trying to get some images out of the docking tunnel. We can see the Earth and the Moon and part of the Moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reid is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reid was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it. So maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, that we'll take sit reps in the blind. And as more and more of the moon is in darkness, we will take any report you have on impact flashes.
All right, Jenny, you'll have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
Local time 5:35 p.m. Central, 6:35 Eastern, 22:35 UTC. It was this time back on Wednesday, April 1st, when the Artemis II crew lifted off from the Kennedy Space Center and began their grand voyage around the moon, culminating at this moment with a grand view of both the moon in the foreground and the Earth in the background in a twin crescent formation here from the vantage point of the Orion spacecraft. Less than 25 minutes are remaining before the closest approach of the Orion vehicle to the moon. Now currently less than 4,200 statute miles above the lunar surface. As we're watching this moment and the approach of loss of signal, or LOS, as we've been hearing, want to welcome in friend of the channel and former editor of Spaceflight Now, current space reporter with Ars Technica, our old friend Stephen Clark. How are you doing, buddy?
I'm doing fine, Will. Doing great, actually. How are you?
I'm doing great as well. It's been a day of firsts, a day of history, and it's frankly an honor and a privilege to be here and share that with you and with our Spaceflight Now family and with all of our viewers around the world. So thanks
Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
The reason why the crew is going to be in a loss of signal with the Earth, as you can see, the Earth is about to slip behind the moon from the perspective of Orion.
That, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still going to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
All right. Now that we've heard those wonderful words from Victor and getting our final views of Earth from Orion before the loss of signal for about 40 minutes, Stephen, it's been quite a remarkable journey these past few days, but most pointedly your thoughts on the lunar flyby portion of this mission as we're about to see our final views of Orion for the better part of an hour.
Well, there's no way I can top those comments from Victor. So I'll suffice it to say that you know, as a lifelong space enthusiast, I've been waiting for this moment for my entire living memory, and it's spectacular to see this view of Earth about to slip behind the limb of the moon from Artemis 2.
Yeah, it's quite remarkable to see the Earth setting behind the moon instead of vice versa. These are views that our generation and the generations that were not alive during Apollo never got to experience. So we're grateful to all of you who are sharing this moment with us here in the United States and around the world. We're about 20 minutes away from the closest approach of Orion to the lunar surface. we'll go ahead and let these final moments play out, of course, keeping this full screen until Orion slips out of communication with the Earth, which should be coming up here in the next about a minute or so, based off the rate that the Earth is going behind the moon. But Stephen, this should be one of the final times, if not the potential final time, that an Orion spacecraft makes a journey around the moon where we will see this loss of signal because of what NASA wants to do with its lunar relays in the future, right?
You're exactly right. NASA has, contract with Intuitive Machines to build a lunar relay network. There's a UK mission that's launching with one of the Firefly landers coming up toward the end of this year, perhaps, as well. That'll be a relay satellite. And of course, China has a couple of relay satellites at the moon right now. And, I think that certainly by the time Artemis 4 gets to the moon, some of that will be in place. But there's a certain drama of seeing the Earth slip behind the moon here, and knowing that those crew members are going to be, really alone and by themselves for the next 40 or so minutes.
Yeah, and I know you've also had the opportunity to talk with the Artemis 2 astronauts, as I've been privileged to do, and in one of the conversations I had with pilot Victor Glover, who we just heard those beautiful words from, he really wanted to impress as we're approaching loss of signal here, as you can see the blue flicker on the screen. He wanted to convey that this is an opportunity for the world to really just have a moment to pause and reflect on the fact that we are all together slipping behind the moon from the perspective of Orion, and just let these 40 minutes be a unifying moment for all of us, as this is a rare moment where not all of us are on Earth, and 4 souls are now out of contact with the planet. And this is a chance for us all to look up and be cognizant of the fragility of humanity and how connected we are in this 40-minute pocket of time. So you can see we're looking back in the white flight control room here. The gallery windows are on the far side from our camera's perspective, or from the camera perspective, with a loss of signal for the next 39 some minutes. Of course, the flight director is having the opportunity to take a bit of a break as we're getting close to a crew swap here. I believe we're shifting over from one of the orbits, or actually that should happen later in the evening, so may just be folks taking a break, getting a chance to stretch their legs, since there won't be any communications coming from Orion back down to the ground, which is, a good moment for all of these folks to really take stock and appreciate where we are in the mission. And Stephen, you've had a chance to be in this room, speak with a number of these folks. Obviously, we're not hearing from them right this moment, but what do you imagine they're feeling at this point in time, knowing that they're handing off Orion for the better part of an hour to just continue and let physics do its thing?
I think you nailed it, Will. This is really the only opportunity they'll have to be in that room and not have, a job to do, so to speak, and to be around their colleagues and to be able to collectively take in the moment, I think would be something. This is really the only opportunity in the mission where they will have the circumstances where, again, they're together with the team and no contact with the Orion spacecraft. So they'll all be counting down, just as we will, for the estimated acquisition of signal coming up in a little under 40 minutes now.
Stephen, of course, we are, about at the halfway point for this mission on flight day 6 here. Obviously we've been talking a lot about the flyby and the mission at this point that has been built up for all of these, years in the planning stages, days in the execution. I wonder, just taking a step back and looking at the totality of Artemis 2 as it has been existing since the last time you and I really had a chance to chat was on launch day. A lot has been going on since then, and we haven't had a chance to catch up, you and I. Your thoughts about what we've been seeing with Artemis 2?
Yeah, I think my takeaway from the first half of the mission is it's gone exceedingly well. I think the only thing of note that they've really been working has been the toilet and the vent, wastewater vent. And, of things to talk about during a mission like this, I think that would be something it may not be, something that's pleasant and polite company to talk about. But I think given all the things that could have gone wrong thus far in the mission, I think the teams are pretty happy that's the main topic of discussion on their troubleshooting loops.
Yeah, it's certainly come up a number of times during the near daily press briefings, which, for folks' awareness, there's not expected to be one of those daily mission briefings today, just because, to be frank, the day is so thoroughly encapsulated with everything that's going on with the flyby, which will extend well into the evening. The lunar observation period is set to conclude at 9:20 p.m. Eastern. Before that, of course, we'll see the upcoming eclipse, where the Orion spacecraft will have the moon eclipse the sun from its perspective, and they'll get another batch of unique observation moments where that's concerned. Stephen, this is the first time that NASA's been able to explicitly put an eclipse on the docket for a lunar mission. It's not something that the Apollo missions had in their resume. What are your expectations of what we'll see with the eclipse moment?
Yeah, I'm not sure what we're going to see live. I think, given the low frame rate and the downgraded resolution that we're seeing through the Deep Space Network, I really don't know what to expect live. I think the real dramatic imagery will be coming later in the downlinks of still photos and perhaps some high resolution video, hopefully overnight tonight or tomorrow through either the DSN link or the optical laser communications link. And yeah, I can't wait to see what the finished product is when we get the full resolution imagery back. But certainly, when the sun goes behind the moon's going to be, dark, and there's no atmosphere at the moon to scatter light. There is a very tenuous exosphere, so maybe we'll see something unusual or kind of exotic looking when the sun passes through that. Don't know. I think that's something that may even be unknown to the crew. Not sure what they'll see until they get their eyes on it.
It'll be a sight to behold. And as we're getting closer to the closest approach, before that moment hits, want to share with you a conversation that we had with Dr. Joel Kearns with NASA about not only this mission, but other goings-on in the realm of lunar science. So here's our conversation from the Science Mission Operations Room, the SMORE, here at the Johnson Space Center. This is Dr. Joel Kearns.
Artemis 2 is in flight right now. It's a big moment for NASA science.
It is super exciting.
Yeah, how are you feeling, now that we're on the lunar flyby day?
Well, I'm incredibly excited, not only because we have a crew actually going out to the moon, right? And they're going to discover things that people have never seen before, but I'm really excited to see what our science teams here in Houston make of that immediately during the flyby, because this is what they've trained for years. and they have been wondering about how are we going to get these questions answered, these 10 science objectives that we outlined for Artemis 2. And this is the day. This is what we're going to see. We're going to see what comes down today.
And of course, this all feeds into the future. Lunar science, might create different CLIPS objectives. There's a lot that we heard about the role of CLIPS in the moon-based planning. So I imagine you're going to be, watching for all the different idiosyncrasies and get your planning cap on for that, right?
Well, that's right. You don't know if what's going to happen today is we're going to get yes/no answers to questions we posed, or we're going to find, hey, we know what everyone thought of this question, and how will that affect what our planning is for the upcoming, human lunar landing missions, but also how we're going to use CLIPS to start putting down the South Pole, the elements of the moon base. And as you know, the administrator has told us to go, 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 but he also wants science on every mission going to the moon. So we are just looking forward today to see what we learn.
And obviously, a big year for CLIPS science too. We've got, a nice handful of missions that are coming down the pipe, right?
Oh, that's right. I mean, right now we've got Blue Origin's Mark 1 serial number 1 South Pole lunar lander just finished TVAC testing at Johnson Space Center Chamber A, Building 32. And we're looking forward soon to having it come out of that chamber and go back to their companies so they can finish the last minute things they have to do. We've got Intuitive Machines getting ready for their third flight. Intuitive Machines' third flight is not going to go to the South Pole. It's going to go to a place called Reiner Gamma, which is what's called a swirl or a magnetic anomaly. And the crew is going to fly over and be able to observe Reiner Gamma today on this flyby today, which is super exciting. It's on the near side, but they're going to be able to see it from a vantage point no one else has ever seen before, right? We have Astrobotic getting ready to fly their Griffin Mission 1 that'll go to the South Pole later this year. And we have Firefly Aerospace getting ready for their second mission. Their second mission will actually go to the far side of the moon. First American landing of the far side of the moon coming up either the end of this year or early next year.
And both the Firefly and the Intuitive Machines missions are unique in that, I know for Firefly this is true, and correct me if I'm wrong on Intuitive, but they both have satellites that will be going into lunar orbit as well to start the early phases of having lunar comms relays, right?
I think, yes, what will happen is that Firefly needs those relays put in place because they're going to land on the far side, and if there's no relays, they're not going to be able to talk to Earth and get our data back. What we joked with them is that they could take relays or they could take a really long Ethernet cable. It didn't matter to us, but they had to get us our data back. Intuitive Machines is going to be on their IM-3 mission. They've told us they're going to start deploying the first of their comm relay satellites, which is going to be used to provide service to NASA, where we actually buy lunar communications from a relay system at the moon, as opposed to always having to use our own deep space network. So we're looking forward to see how they do that, how that works, because we have a bunch of people that would like to buy a comm relay service.
The last time you and I had a chance to talk was before the big moon base announcement, and it's calling on CLIPS to, really figuratively and literally carry the load for that early construction. In talking with the different CLIPS contractors, how are they feeling about making that transition? How is the CLIPS team from the NASA side feeling about, really having to step that up in a big way?
Well, on the NASA side, we're super excited because our CLIPS original effort was laid out to say, okay, every year we will select 2, and that means several years from now 2 will fly to the moon. So that's how we were set up, but there was nothing really stopping us from scaling that up. Now the administrator gave us the charge to scale it up to help enable moon base. The NASA group is really, really pumped because we have all these places we like to send landers and all these payloads and experiments we'd like to do in the moon, almost like a parking lot waiting. This will provide an avenue for that, but what it'll also do, it'll allow us to let the CLIPS companies really step up, and instead of, say, working on one lander for a while before they work on the next, they're going to have to, in effect, have an assembly line or a manufacturing line of landers. And as part of that announcement the administrator made on Ignition Day, we posted the draft request for proposals to those CLIPS providers of what we're going to ask them to do, and they're very soon going to have to start writing proposals to get all those assets to build up the moon base at the South Pole. So they're really excited too.
We talked about a number of companies that have CLIPS missions this year, but one that made an announcement but moving to the right was the Draper iSpace US team. Can you talk about sort of from what you understand about where they are with their lander and the changes that they've been making with the engine and how that's impacting CLIPS?
Well, they have changed their engine from the iSpace USA company, which is a subcontractor to Draper, to do what's called the CLIPS CP-12 mission. And when you change your engine, you really end up changing a lot about your lander. You change your tanks, you change how you're controlling your propulsion, things like that. They've also been reacting to what the lessons they've learned out of their Mission 1 and their Mission 2 that was sponsored by Japan. So they have told Draper that they want to consolidate on a fewer number of different types of landers, and they've proposed the plan back to Draper, which Draper is bringing to NASA. So we're going to have to evaluate that plan and see how that fits within the context we're in now, where we want to go faster and we want to do more. And that mission is a really important South Pole mission. It's a South Pole far side mission. So we want it to move earlier. We don't want it to move later.
Does that change in their date of planning now for 2030 change the science that's going to fly in that, or is that pretty set and baked at this point?
The NASA science is very set, and it's been set since Draper won that particular CLIPS task order, but it's always up to Draper and iSpace to say what non-NASA payloads they're going to fly in that mission.
Last question for you. There's going to be a lot of observations made by the Artemis 2 team today. Is there a particular feature on the moon that you're most looking forward to seeing their photos of?
Oh, well, I have some favorites. This is not like a science priority because they have the priorities laid out, but I'm really looking forward to see the Oriental Basin and the Ohm crater north of that, and I'm also looking forward to see what they can discern out of areas that are called the South Pole Aiken Basin that run roughly from, it's on the far side, it runs roughly from the South Pole up to a place called Aiken Crater, because that's an area of really intense scientific interest where I think someday we will send a sample return mission, or we will even send astronauts to bring the samples back. So I'm really interested to seeing what they see out of that today. But if you were to ask a different lunar science person, they probably have a different list of things. You know, like, all my friends would say Aristarchus, which is a place you could say you could see on the near side of the moon. And we're actually getting views of Aristarchus now with those different angles where the crew is seeing it, which no one's ever seen before.
Yeah.
But it's not one of my personal top 3, although it's a really neat place.
Well, Dr. Kearns, we're looking forward to seeing you back in Florida for the next CLIPS mission. Thank you, sir.
I'll see you then.
And again, that was NASA's Dr. Joel Kearns. We're approaching the point where the Orion spacecraft will be closest to the lunar surface. That's coming up here in less than 3 minutes. Stephen will talk more about what we discussed this morning with Dr. Kearns and I, but you know, as we're looking here in the SME, got some views in the SMORE earlier. That's where the interview was conducted, the SMORE. But lot of scientists in this room that have been eagerly pouring through the descriptions that all 4 of the Artemis 2 astronauts have been feeding down. You've had a chance to talk with some of these lunar scientists as well. They just must be abuzz with excitement.
Yeah, I think so. They've been training alongside the crew of Artemis 2 since they were named 3 years ago. And what's interesting is they had to plan all these different trajectories because based on the day they launched, they would be seeing different parts of the moon illuminated. The trajectory would be different each time, each day. So April 1st, of course, was the day they launched, and they had a plan for April 1st that they're now putting into execution today. And you know, the bonus objective to launch on April 1st is this solar eclipse that'll be coming up after they reacquire the signal from the Orion spacecraft. The sun will be passing behind the moon from the point of view of the astronauts, and that's something that was only available on certain select launch dates, and April 1st was one of those.
Yeah, and of course the possibility for greater illumination of the moon would have happened had the launch slipped further into the early April window of opportunity, but certainly, you know, based on everything that we've heard from the crew, and especially from, you know, Victor so vividly about the starkness of the details there at the terminator, which is the point at which the illuminated side of the moon crosses over to the dark side from the vantage point of these astronauts, was quite stark. So you can see in the clock in the upper right-hand corner of the screen, we are now less than 30 seconds away from the Orion spacecraft making its closest approach to the moon. We'll see if there are any remarks made by NASA as this milestone happens. I'll count it down for you here in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and the closest approach achieved at a distance of 4,067 miles away from the lunar surface as planned. The Orion spacecraft continuing to make its slingshot around the moon. It'll be the furthest from Earth coming up. Let's listen to NASA's commentator make some remarks about this. Let's listen.
At MET, 5 days, 25 minutes, and 34 seconds, and we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon.
Now a little bit beyond a minute from the closest approach to the moon. Coming up next milestone to mark will be Orion's furthest distance from the Earth, which is set for 7:02 and 51 seconds p.m. Eastern. So within the next minute. Now 6:03 p.m. Central Time, 7:03 p.m. Eastern. The point where Orion is the furthest from the Earth has now elapsed at a distance of 252,756 miles. Bringing back in our friend and fellow space reporting colleague, Stephen Clark. You know, Stephen, as we heard in some of the pre-flyby news briefings throughout the course of this mission, you know, the folks at NASA, at least in that specific venue and those specific individuals, you know, like Mission Management Chair John Honeycutt said that, you know, these distance records are all well and good, but that's not the most important thing in his mind when it comes to the Artemis 2 flight. But I guess just a two-part question. Your thought on, you know, these distance records that have been achieved by the Artemis 2 crew. Just want to refer back actually to a tweet that you wrote about 4 hours ago saying that you were, you know, quote, not ready for the emotional weight of the moment when Reid, Victor, Christina, and Jeremy became the most distant explorers in human history. I wonder if you can bring us into what that moment was like for you, having covered human space exploration for as long as you have. what was running through your mind and your heart, realizing that these 4 humans have now gone further than anyone has ever before?
I think one thing that came to mind is we're lucky to be alive at this moment in the history of human exploration, not even just space exploration, but just human learning and human knowledge and growth as a species. I think we're really lucky to be here on this planet to witness a new record being set like this. And of course, the distance record is not the most important part of the mission, and getting the crew safely home certainly outweighs the distance record. Even just testing the Orion spacecraft and learning about how it behaves in space, more important than getting the distance record, in terms of implications for the future of NASA's exploration program. But I think it does matter in the end that they have set the record, and I think that will be one of the more memorable things about this mission. Will be having set the distance record to be broken at some point, TBD, to be determined in the future. Probably not for a while, given the focus is going to be on landing on the moon for the coming years, not doing another trajectory like this one. And also these of Earth setting behind the limb of the moon from a different perspective than we got during Apollo. These photos will look much different than they did in Apollo, and the scientific and aesthetic output from the imagery and observations from the crew on this mission will differ from Apollo. So I can't wait to see those images make their way back to the ground in full resolution.
Yeah, and as you mentioned before, the closest approach happened. Part of what will be happening today once Orion emerges from the far side at this point and then going into, or at that point and then going into the night, and certainly while the crew is in their sleep period, they'll be using both the Deep Space Network to downlink a lot of the images that have been captured by the crew, as well as using that optical relay demonstration that is a part of this mission. For those who may recall, on the Psyche mission, they used a similar optical relay demonstration as they're working to prove out the capabilities of using optical comms as opposed to radio communications, as has been the case using the Deep Space Network in recent years. But of course, we've got many commercial companies like SpaceX that are pushing the boundaries on optical communications, and if they can take some of the impacts off of the DSN or the Deep Space Network, Stephen, I'm sure that that's something that is going to be very enticing for NASA to do, especially when we are looking at some point in the future of sending humans out to Mars.
Yeah, I think the optical communication, laser communication is something that will be critical to the future of lunar and Martian exploration and even further into the solar system. And I think you touched on it here, but the point deserves to be underscored that that offloading some of the demand from the Deep Space Network, I think, is very important for NASA. I'll be interested in hearing how the Deep Space Network, those 3 antenna sites in California, Spain, and Australia, how they performed during this mission, and what effects, if any, there were on NASA's other missions that are out exploring the solar system. During Artemis 1, DSN was really pushed to the limit, and of course that mission didn't have crew. It was a longer mission, more than twice as long as this mission will be, so that certainly was a factor in stretching out how long other missions might have been impacted. But this mission has more downlink requirements, so more data coming down in a shorter period of time. So I'm interested in hearing how these very venerable or aged antennas that are in many cases many decades old, how they hold up and how the entire network performed during Artemis 2. I know NASA also is building out a dedicated lunar relay network. They call it by the acronym LEGS, LEGS. Can't remember what that stands for exactly, other than the L is lunar. but it's a dedicated network of antennas that will go alongside the Deep Space Network just for lunar missions, and that will help unload some of the demand from DSN during future Artemis missions. And again, and once they have the lunar base, permanent operations, full-time round-the-clock operations on the moon certainly will need its own dedicated network.
Snappy Google search got me the answer for you, Stephen. It's the Lunar Exploration Ground Sites.
There we go.
Currently at, let's see here, 6:11 p.m. Central, 7:11 p.m. Eastern Time. Slushy o'clock, if you will. 23:11 UTC for those around the world. The predicted acquisition of signal was set for about 7:25 p.m. Eastern Time, so we've still got about a little more than 10 minutes remaining before the contact with the Artemis 2 astronauts is reestablished. In the big box, you're looking at a visualization of the Orion spacecraft, courtesy of NASA. Stephen, as they're busy behind the moon, one of the things that they're going to continue to try and image and keep an eye out for are those impact flashes that were referenced by, forgive me, folks, I'm not sure if it was, I think it was Jenny Gibbons, the Capcom, before they went behind the moon and lost communications for this pre-planned blackout period. But Stephen, I'm sure if we are able to get, a photo of an impact flash by one of these astronauts, that would be quite an extraordinary thing for the 21st century imaging opportunity that these astronauts have.
Yeah, definitely. I think that would be a great bit of science and great bit of luck that would be involved in not just having an impact occur while they're over the night side of the moon, but having it occur when their camera shutters are open. So that would be really spectacular. I presume on the back side of the moon, they're working with pretty slow shutter speeds. So shutters may be open for, quarter second, half second, if not longer. But still, I think will require some fortune to get an image like that.
Yeah, and for those curious about how the Artemis 2 astronauts trained for this extraordinary moment of high-stakes photography, we've got a video up for you on our YouTube channel here. So if you haven't had a chance to check it out, highly recommend you do so. If you want to put us on mute for a second, pop over, watch that video, come on back, or put it up in 2 tabs if you've got a computer and you have window space for that. It's a good little video with one of the photography trainers, as well as words about what they were anticipating this moment would be like from NASA astronauts Christina, Koch, and Victor Glover, along with some additional commentary from Dr. Kelsey Young. So, Stephen, the astronauts are getting ready to reemerge, and we've talked a little bit about the solar eclipse moment and what we're hoping that will be, when we get the high-resolution photos back from the crew. There were a number of things that were mentioned in our conversation with Dr. Joel Kearns that we recorded with him this morning in the Science Mission Operations room here at the Johnson Space Center. I wonder, what from that conversation jumped out to you, whether it was one of the CLIPS elements or what he's watching for on this mission.
I think probably the CLIPS missions, because I think that's something that we've heard a lot in the days leading up to the mission and in these mission status briefings about what the observation plans are for the Artemis 2 mission. But NASA has under the ignition announcement a couple of weeks ago about kind of accelerating lunar exploration and focusing the agency on that, talked about I think one robotic lander per month or thereabouts, starting as soon as next year. And that is going to require a dramatic increase in funding, dramatic increase in capability from commercial companies in terms of their production of lunar landers. Right now, the companies that have landed on the moon, so Intuitive Machines and Firefly, are launching maybe once every year or two. And they're the only two companies that have landed on the moon successfully so far. Be interested to see how the Blue Moon lander performs from Blue Origin, and even if it's successful, how quickly can Blue Origin ramp up their manufacturing of future lunar landers as well? So NASA has a broad mix. I think more than a dozen companies are on the CLIPS contract that are eligible to compete and win task orders for robotic lunar landers, but only two of them have delivered, and only really one of them, Firefly, was completely successful. So there's a steep learning curve ahead. NASA today, and even since the days of Administrator Bridenstine in the first Trump administration, talks about shots on goal. Um, you know, I think they're going to have to take a lot more shots to really fine tune the success rate and get the success rate up for landings for each of these companies, and and send these precursor missions to the moon. And eventually NASA wants to use some of the robotic landers as heavy cargo missions. So these companies are going to have to build heavier landers down the road as well. And this is excluding, this is not mentioning the elephant in the room, which is Starship. And it too will have a cargo capability as well. But it's a long way from getting to the moon, just like these other CLIPS companies are.
Yeah, just speaking of the Starship of it all, of course, the latest, I believe, that we've seen as far as regulatory filings suggest that, as you'd reported from the Glenn Symposium, last year, I think at this point it was, that heard from Bill Gerstenmaier that the next flight, Flight 12 of Starship, the first version 3, would be a suborbital mission, and that if all went well, Starship Flight 13 would try to place Starship Upper Stage into low Earth orbit, and that seems to be the plan if the regulatory filings are bearing out. It's going to be interesting next year to see how the Artemis 3 mission shakes up now that it is no longer the lunar landing mission that it once was prior to the ignition event, as you were just describing. This will be a really interesting chance to see how these two human landing prototypes are shaken out. Stephen, how are you feeling about going into this final, I say back half of the year? It's only April 6th as we're talking right now, but there's a lot that we're going to hopefully need to see from both the Blue Moon and the Starship programs before either of them are in a posture to support an Artemis 3 style mission next year, even one in low Earth orbit.
Definitely. They have a lot on their plate, but each company does. So first of all, Starship, to do a low Earth orbit mission that takes the in-space propellant transfer, the refueling demonstration out of the critical path for Starship to get to Artemis 3, but they still need to demonstrate life support system on board. We haven't heard from NASA, and this goes for both Starship and Blue Moon. Will SpaceX and/or Blue Origin be required to do an uncrewed test flight of their landers in low Earth orbit with the full up life support system before getting approval for Orion to come and dock with crew and having astronauts actually board the human landing systems in low Earth orbit? Will the crew definitely board the HLS, the landers in low Earth orbit on Artemis 3, or is there a chance, if the life support system isn't ready, that they just dock with the lander and do some maneuvers? In Apollo 9, they had one crew member stay inside the command module, so that's the analog to Orion, and they had two crew members get aboard the lunar lander, so that would be the analog to Blue Moon or Starship, and separate out to dozens, if not more than 100 kilometers from one another in low Earth orbit while they did maneuvers. Would Artemis 3 follow a similar profile, or would it be different or less ambitious if if the full complement of life support and other systems aren't ready on Starship and Blue Moon. I'm sort of thinking out loud here, but we haven't, they're still nailing down what the mission profile is going to be for Artemis 3. We know it's going to be in low Earth orbit. They'll dock with one or both landers in low Earth orbit, but we don't know what they're going to do when they get there. And we also don't know exactly what altitude they're going to go to or inclination. And a lot of this also has implications for whether NASA flies their final interim cryogenic propulsion stage, their final ICPS stage on the Space Launch System on Artemis 3, or do they hold on to that for Artemis 4? That all depends on what kind of performance they need from the rocket, and that you can trace that to back to first order requirements, what the mission's goals actually are.
Yeah, there's a lot to flesh out with this mission, and if as we're talking out loud about what the next year might entail and what version of Artemis 3 we end up getting, of course, NASA is still, as we understand it, refining their crew selection for the mission, and that will be variable depending on who they feel are the right people to test this particular style of, at minimum, low Earth orbit. Might possibly fly into a high Earth orbit with one or both of the landers, but a lot of things to think about and consider when we learn of who the crew is, what exactly their mission objectives will be, and in what state of functionality will either Starship and or Blue Moon Mark II be. They're all good questions. I think as you say, Stephen, at bare minimum they need to dock with one of the landers. I think that's obviously not in the planning room, but I feel like that's pretty much a non-negotiable. Like you gotta
Right.
run this mission at least with the docking capabilities, just to know how well Orion does when it gets into proximity with these massive landers, and then just to test out the docking mechanisms in a real world environment.
Exactly. I mean, why fly the mission if you don't do that? So at a minimum. So I definitely am on the same page with you there. And if they're waiting for the full life support system and to get Starship and or Blue Moon close to at a more advanced state of readiness for a potential lunar mission down the road, it's going to be tough to get to that stage next year, in my view. If they go on a more bare bones approach and simply dock, then I think 2027 is a lot more doable. So big decisions ahead.
Indeed. And we have video back from the Orion spacecraft. The crew has emerged. You can see the crescent Earth there just beyond the edge of the moon, which is, we're seeing the edge of the dark side, so it's kind of hard to make out against the Earth there. The flashes of the blue is, communications are being reestablished. They're not quite solid yet, as you can gather from the flashes here, but we should be hearing from either the Capcom Jenny Gibbons. More than likely, Capcom Jenny Gibbons would have communications with the crew before Dr. Kelsey Young, given that she is the main point person from an auditory perspective to the astronauts. Reestablishment of communications happening just about on schedule from what was predicted for the acquisition of signal. Of course, we will stop our commentary once they jump in and we hear from either Orion down to Earth or vice versa. So in anticipation of that, we're going to go ahead and just calling an audible. We'll pause in our commentary just to ensure that we're not stepping on that. And we'll be back with you with additional words here in just a minute. just to not sit in silence for too terribly long, if you're just joining us, the Orion spacecraft has emerged from behind the moon. As you can see, we've got live pictures coming back down from the Orion spacecraft. You can see the crescent Earth and a view inside the cabin now. Standing by for communications either from Orion down to Mission Control Center Houston or from Capcom Jenny Gibbons as the crew now back within the field of communications.
Houston, integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected, we copy. Those of us that can are looking back.
We are happy to say we copy.
Good words between Capcom Jenny Gibbons on the ground and NASA astronaut mission specialist Christina Koch up on the Orion spacecraft that the crew named Integrity. Now that the crew has made their way past the far side of the moon and is back in communications with Earth, also passing their furthest point from our pale blue dot, they are now officially making their way back home. It's a nice sentiment from Christina Koch, closing her initial comments saying, "We will always choose Earth. We will always choose each other." Stephen, it's a profound thing when astronauts are preparing to depart historically from the International Space Station and make their way back to splash down, if they're coming back in a Dragon spacecraft, or land if they're coming back on a Soyuz. It's quite something unique to hear and see that the crew of the Orion Integrity are now beginning the long voyage home. We've talked about a lot of aspects of this mission, but the fact that they are homeward bound, your thoughts on that piece?
Yeah, this is almost exactly, chronologically, almost exactly the halfway point of the mission, and certainly if you plot their trajectory, also the halfway point, reaching their apogee from Earth, more than 252,000 miles, Earth's gravity now pulling them back to their home planet, and we'll see the velocity on that rendering start going up again after being slowed down after slowing down throughout the mission since the translunar injection burn, velocity heading back up as gravity pulls them home. And I think they'll have an off day tomorrow and have some time. We often hear space missions compared to marathons or sprints. Space station expeditions, more like marathons, they're 6+ months long. And this has been a sprint from launch until today. The crew has been very busy with testing systems on the Orion spacecraft, manual flying, lunar observations, preparing all their gear, equipment for the lunar observations, troubleshooting the toilet, all sorts of things have kept them very busy. And I think they'll have some off-duty time tomorrow, and then getting ready for that critical reentry on Friday evening. This mission has flown by from my perspective. The last 5 days have certainly gone by quickly.
Yeah, I think sentiment that I would pose it as is it's been a whirlwind. Certainly to say it's gone by quickly is definitely in line with how I've been feeling here in Houston. It's a busy day for us covering the mission tomorrow, a little bit of a lighter day, as you mentioned, for the crew. Although, that being said, an important crew day tomorrow, since around 2:40 p.m. Eastern, 1:40 p.m. Central, they will have an important moment marking another first for human spaceflight, where they are set to have an audio conversation with the astronauts on board the International Space Station. And then there will be a debrief of the lunar science that they have been so diligently gathering today. This will be, this whole mission has been the first time that we've had, astronauts in low Earth orbit as well as astronauts in deep space. And while I'm imagining it'll be a big moment for all of the crew members on Orion to be able to talk to their colleagues on the International Space Station, especially, though, for Christina Koch, a really unique opportunity where her colleague, fellow NASA astronaut Jessica Meir, who shared the distinction of being the two women who shared the first all-female spacewalk, in fact, the first 3 all-women spacewalks.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
That's great. Great to see the light of day as we head back to
little bit of a tough comm situation here with the words that Commander Reid Wiseman was about to express down, and of course we'll pause again if they try to take 2 here. But in the interim, Stephen, the fact that both Christina Koch and Jessica Meir, just by sheer coincidence of when their space flights happen to happen, it's just quite remarkable that they are going to be able to talk to each other from this grand distance of just outside of the lunar sphere of influence for Christina and, in low Earth orbit for Jessica.
Yeah, I think that'll be really cool to hear that conversation as the 2 crews talk to one another from such vast distances. I remember I think it was during the shuttle program when a few of the shuttle missions did not go to the International Space Station, such as the final mission to service the Hubble Space Telescope. They were able to talk between the shuttle and the space station briefly during that flight. But of course, and it's really cool to have 2 spaceships calling one another in space, but the distances there were a lot different than what we're going to be experiencing
tomorrow. I'm not sure what the distance will be to Earth at 2:40 p.m. Eastern tomorrow, but more than 100,000 miles, maybe close to 200,000 miles. That is going to be a really, really cool a conversation. And I think the radio light delay or light time to the moon is like between 1 and 1.5 seconds. So that doesn't sound like a lot either, but I think when you think about the speed of light and how fast that is, 1.3 some odd seconds is really makes the distance seem that much larger to me than you might think otherwise, because speed of light is something unimaginable for all of us, and the light delay from the moon is really kind of noticeable in some of these communications that we're hearing from the crew sometimes.
Yeah, exactly. Just want to make a quick note of what we're seeing on screen, the flickering with the Orion spacecraft view and now the blue screen. They're just having a little bit of
industry.
challenge with the comms here, as we can see, but those visuals will be reestablished in the not too distant future. Just as you were making those remarks, Stephen, I couldn't help but think that, for all the Trekkies out there, this is, sort of a seminal moment in, getting towards a Star Trek-like future where you've got one ship hailing another ship for all intents and purposes. And, at some point, maybe we'll have a similar first with a spaceship bound to Mars and, whatever commercial station has replaced the International Space Station at that time, and maybe a three-way call with a future Orion spacecraft that is entering into lunar orbit. I mean, it's a very exciting future that we're just on the cusp of, and obviously we want to keep things, professional here on the channel, and, make sure that we're giving good, cogent commentary and not being hyperbolic in what we're saying. But it's kind of cool to stop and think about this singular moment in time and what it signals where we're going.
Definitely is, Will. And just imagine setting up that Zoom call between between the Earth, low Earth orbit, moon base at the South Pole, and Orion spacecraft approaching, and an expedition on their way to the Red Planet. That's going to be quite a moment. But just to bring ourselves back to reality, I believe in that future. I believe that will happen. But we have a long, long way to go, and I try to set my sights a little closer earthbound, so to speak, and I'm not sure I'll be around for that moment, but it'd be cool if I was.
Oh, I think we'll all live to see it. Now, whether you and I are still in the business of covering space news, we'll see.
Integrity Houston for another comm check.
We have you loud and clear, Houston.
All right, Integrity, we hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. We moved it, and we are in bias tail to sun.
Okay, Houston, you're coming in loud and clear, and copy, we're in bias tail to sun now.
Affirm and Integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
Okay, copy that. We were just excited that we got to share in that you, the MER, and Mission Control flipped your patches around, and that side of the patch is getting to see the light of day. Thanks for sharing that with us.
Our pleasure.
Local time here, 6:42 p.m. Central, 7:42 p.m. Eastern, 23:42 UTC. Just as a reminder to folks of where we are in the timeline, the next big milestone that is out ahead for the Orion astronauts, or the Artemis 2 astronauts on board Orion, I suppose, is coming up in less than an hour's time. At about 8:35 p.m. Eastern is when the crew is set to experience an eclipse of the sun. As you can see in this visualization, the sun is getting closer to moving behind the moon from the perspective of these Artemis 2 astronauts. And like those of us here in North America, as we saw the great solar eclipse event back in 2024, so too will these Artemis 2 astronauts get to see their own bespoke solar eclipse opportunity. Of course, they had to travel a little bit further than some who wanted to see it here in the United States, but I would say based on the visuals we've seen so far and the descriptions that we've heard from them, it was well worth the multi-day ride. On the far left-hand side of your screen, you can see the main engine of the Orion spacecraft, which this particular engine has, like is the case with a number of pieces of the Artemis architecture, it has ties back to the shuttle program. In fact, this main engine has flown about half a dozen times as part of the Space Shuttle Atlantis orbiter. And we've got a new clock to share with you now. As you can see in the upper right-hand corner of your screen, we are, I will call this E minus 50 minutes, 12 seconds and counting to the beginning of the eclipse period for the Artemis 2 crew. Now getting more light inside the Orion capsule as the sun is at a different angle compared to the windows, and they're not in a distinct lunar observation period for the crew. They're taking a bit of a break now, given that the windows are not in a good observation angle. As you can see with this visualization, they are pointing about 90 degrees away from the moon. Steve and I know we're still Stephen, I know this is still a few days out before the crew actually re-enters Earth's atmosphere and begins the energetic period of re-entry leading to splashdown. But, you know, this will be just the second time that we are seeing an Orion capsule enter back into Earth's atmosphere using the same heat shield that flew on, I mean, not the heat shield that flew on Artemis 1, but the same style of heat shield without the improvements that are being added to the heat shield for Artemis 3. Difference is this one is making a different style of re-entry, but that was a big reason why Artemis 2 didn't launch until this year, as we're a couple of days out from that really big moment that John Honeycutt, the mission management team chair, says that he is watching and you know, anxiously waiting to see them come through and see good main shoots. How are you feeling about re-entry now that Orion is making its way to that point?
Integrity
on the other side
Houston
of this.
for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first two are for timeline. First of all, Reid, for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the oxone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy y'all. Thanks for those words, Jimmy.
As we await further communication between the Orion spacecraft and Earth, Stephen, the question I was posing to you just before that about your thoughts on the reentry period of this mission.
Yeah, I think that's going to be another moment of high drama as the spacecraft comes screaming back into the atmosphere. They'll be setting a new velocity record, if my memory serves, and yeah, they've had to redesign the reentry profile given some of the damage and the heat signature they saw in the heat shield during Artemis 1. So they've going to hit that reentry corridor and splash down in the Pacific Ocean off the west coast of Southern California. So I'm interested in hearing maybe tomorrow or Wednesday we might get a weather report. Will, you may have a better clue of when we might have an idea of when they'll have an assessment of what the winds and waves are going to be like in the splashdown zone. They have several locations they could go to, correct?
Yeah, and I believe the first we'll hear on weather may be even as early as tomorrow preliminarily, but certainly by Wednesday that will start to really take shape, and we'll get much better weather data just a few days out as opposed to majority of a week. But that is something that we asked the mission management team, John Honeycutt, the chair, about a couple of days ago, and at that point, as it was just first brought up, it was too early to really give a good read on. But the sea state is going to be very important, since depending on if they're setting their splashdown right on top of where they're originally planning, that would create about a much shorter timeline to get the helicopters from the naval recovery ship out to the Orion spacecraft and offload the astronauts, get them back onto the ship, and then fly them to land at San Diego. If they're a good piece off target from the planned splashdown site, then that will just elongate the recovery timeline for the crew and mean more time in the water potentially, which they've trained for a series of different scenarios, as you, Stephen, know, but for our audience, they've the U.S. Navy and all of the partners with NASA, as well as the Kennedy Space Center, who's in charge of the recovery operations for the Orion spacecraft. They've all been working in concert and preparing for all the various types of scenarios that would see the astronauts return to Earth, whether that was going all the way back to if they had needed to perform a pad abort and recovering Orion from the Atlantic Ocean all the way up through the ascent corridor and the various abort sites along the climb uphill, and now as they're preparing for the return in the generally planned area off the coast of San Diego, they are thoroughly well versed in all different manners of recovery efforts, whether that's more nominal or if they've got, knock on wood, God forbid, an injured astronaut during the reentry process. They are trained in a variety of ways to respond as needed. Time now 6:57 p.m. Central, 7:57 p.m. Eastern. 0357 UTC for those around the world. We are a little bit more than half an hour away from when the eclipse with the sun for
Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
As you just heard, we'll be in another comms blackout between the Orion spacecraft and the ground there in Houston as they do a handover from the ground side communications. As we're approaching this period of communications blackout, I want to go to another conversation that we had earlier today with Dr. Sarah Noble, one of the science leads that has been heavily involved with the planning for the Artemis 2 mission for several years at this point. So here is our conversation with Dr. Noble about her expectations going into this flyby period for the Artemis 2 mission.
Lunar Flyby Day, this is what y'all have been building towards for half a decade now. How are you feeling?
Feels like Christmas morning.
Oh, good. And you get a beautiful present to open up once the science data starts coming down. You know, in those early observations, as the crew is, making those real-time notes and sending them back to you, what are you going to be most particularly listening in for? What verbiage is going to really pop out for you and your team?
We've already been hearing them as they're, approaching the moon, making some descriptions and talking to us about the solar color differences, the albedo differences. They're already doing a great job of that. So more of the same. I think it's great, and I think today, what we are really trying to do is, take it all in and get ready for tomorrow morning when we will actually have an opportunity to have a crew conference with them and sort of pick their brains a little bit more about the things that they have told us and seen.
And so that's an important distinction to make. What's going to be their focus in verbally and, photographically getting back to you today? And what are they kind of, holding in their back pocket to make sure that you have a more robust conversation tomorrow when there's time?
So today, we won't be directly hearing most of their notes. They'll be recording them on their personal tablets, and then we'll get those recordings up overnight. And so our crew will be working late trying to get all of that stuff together for the science team to run through tomorrow morning and see what more questions that they have that they want to just dive in and pick their brains a little. Oh, what did you mean when you said this, or that sort of thing.
And of course, the science plan has been baking for a while, but I imagine it is set now. It's come out of the oven. Where do things stand as far as the number of sites? Because yesterday we heard 30. What's the final number of targets that they're going to be attempting to achieve today?
Yeah, so there are 30, including things like sunrise and sunset and earthrise and earthset. There's a range of targets. There are a couple of targets that they will revisit more than once, sometimes with the same crew, sometimes with the other crew. So we get a couple different perspectives, different lighting conditions on a couple of those targets. So it's a good list. They worked really hard to fit it all in and make sure that we've really optimized it for our science objectives.
And what are some of those sites that were important to revisit, and how did the science team pick those in particular?
One of the big targets, obviously it looks like a big target, right, is Oriental Basin.
Yeah.
It's amazing. We can only sort of see half of it from our, so these beautiful images already that we're getting back where you can see the whole basin, I think everybody's really very excited about. And so that is one of our big targets too, and they will spend some time discussing that and really taking a good look at it from a number of angles.
And just last question, as the science team has spent so many, hours and years of their lives, in your life, preparing for this moment, how are they, making sure they're locked in as they're getting a lot of great data that I'm sure is going to, excite, and there's going to be a lot of emotions going into it, but, Victor is always talking about you got to focus up when the time comes to, when it's game time.
Yeah, I'm not worried about that. I actually am worried about the opposite. I keep thinking about today like a wedding, right? Like you're busy and there's all of these things and everybody needs your attention and all the things, but like you should take some time to like take it in and be in the moment and make sure that you are really absorbing that you're in the moment. So I keep telling my team to make sure that, as they go through this day, they take a minute to think about what we're doing.
I appreciate this is the first, quartet that's setting eyes on the lunar surface for the first time in 50 plus
deal.
years.
Yes.
Thank you, Dr. Noble. Really appreciate it.
Yeah.
And our thanks again to Dr. Sarah Noble for the great conversation earlier today. That room we were in, the Science Mission Operations Room, one of the first places where scientists with NASA will be taking downlinking, and processing the bounty of high-resolution images captured by the Artemis II crew during their lunar flyby. Well, speaking of byes, want to say goodbye, if you'll pardon the dad joke here, to our friend and colleague Stephen Clark with Ars Technica, who's been kind enough to share some of his time with us today in this moment of history. So, Stephen, your final thoughts before we turn you loose and let you go ahead and enjoy the rest of this mission today.
Well, it's been a pleasure sharing history with you once again, Will, and the rest of the Spaceflight Now team. And again, I think tomorrow getting some of these images back will be really, really a sight to see. I did catch a glimpse of Christina Koch looking at a tablet with some of her photos on it inside the Orion cabin a few minutes ago, and looks like she had a really zoomed in 400 millimeter shot of Earth set, I believe, the Earth setting over the limb of the moon. So it was just a few pixels wide in the image on the tablet coming back from the Orion spacecraft in this internal view, but cannot wait to see that in a full 20 plus megapixel glory.
We will all be very eagerly awaiting everything that they are sending down as soon as they possibly can get it to us. We'll be sharing and talking about it as the world will be. Stephen Clark, for those just jumping into the conversation, a space reporter with Ars Technica, former editor of Spaceflight Now. You can follow his work over at arstechnica.com and follow Stephen specifically on social media. He's at X at Stephen Clark 1, and that's Stephen with a PH and the numeral 1. Stephen, thanks for joining us today. Really appreciate it.
Of course. Thanks for having me anytime.
And of course, this is not the end for the rest of us here at Spaceflight Now, as we'll continue to follow along with the major milestones on the Artemis II mission. If you are just joining us here, just past the top of the hour, it's 7 o'clock in Central Time, 8 p.m. or 8:05 p.m. Eastern, 0005 UTC for those joining around the world. You're watching Spaceflight Now's live dedicated coverage of the flyby of the moon by Artemis II astronauts Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. The crew has conducted the flyby of the moon that took them as close to the lunar surface as they possibly will be on this mission, and the closest that humans are set to be before NASA's plans to return humans to the lunar surface, as currently planned, happening in 2028, if all goes well. The clock you see in the upper right-hand corner of your screen, that is counting down to the start of the eclipse period, with the sun coming in front of the Orion spacecraft, or the sun going behind the moon from the perspective of the Orion spacecraft. Time now 7:16 p.m. Central, 8:16 p.m. Eastern, 0016 UTC. You're looking in this large box view of a visualization of the Orion spacecraft in relation to the moon. As you can see, the sun is getting closer to the moon from the perspective of Orion. That's because the trajectory has a planned eclipse period for the Orion spacecraft. As is the case with those of us here on Earth trying to view an eclipse, the Artemis 2 astronauts also each have a pair of eclipse glasses so that they're able to watch the sun as it sets behind the moon and enjoy just under an hour of eclipse time.
Houston integrity in the blind. High priority PAO activities on Reid's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
Seven 20 p.m. Central, 8:20 p.m. Eastern. .0020 UTC. Want to thank a few folks for your ongoing support of our marathon day of coverage here, covering the lunar flyby of the Artemis 2 mission. Let's see where we left off. Thanks to Melina for the £5 super chat. Really appreciate that. Asking if a crewed moon base is possible within the next 15 years. as it's taken 50 to return to the moon, and offers a hello from the United Kingdom. Well, that is certainly NASA's intent, as our audience may be aware. The NASA administrator announced that intention to get things moving in the direction of a crewed lunar base that will be built out across 3 phases and cost on the order of about $20 billion, at least for the U.S. portion of the lunar base development. So we'll see, right? I mean, it depends on how the execution goes and the ramp up from the commercial partners that are going to be involved with it. And of course, the preservation of congressional backing and congressional funding for these lunar base objectives. Now that that has been decided is the course that NASA will take, as opposed to really starting out and focusing first on a lunar gateway and then building out base elements. MedTech, been a channel member with us now for 9 months at the pad leader level. Appreciate your ongoing support. MedTech says, my dad worked on the DKSY electronics. It's very cool. Wish he was alive to see this. Got to meet Rick Armstrong recently, who thanked him on behalf of his dad. Well, that must have been a really special moment. Glad you were able to have that opportunity with Neil Armstrong's son. Robbie with a 5 CHF super chat. Some nice words and great content. Thank you, Robbie. Len Curtis Lives upgraded their membership to the mission specialist level. We really appreciate that additional support, Len Curtis. Thank you to my mother, Mary Robinson, for the very generous $50 super chat. Thanks, Mom. I'll go a good way towards caffeine re-up here for me here at in Houston and for the team back in Florida. M12407 with a $2 super chat, one of our channel members, who says, loving this now, witnessed Mercury through Artemis. That is quite special to have seen the full range of human space flight from the American space program perspective. Quite the legacy. Want to welcome a new channel member, Joy Castful, checking in with membership at the pad leader level. And final comment for now, Wolverine Warlord have been a member with us now for 30 months at the launch director level. Thanks for sticking with us, Wolverine. He says, do you know if they will be able to get any imagery of the items left over from the Apollo missions? Also, great job on launch day. Thank you. Launch day was another marathon. Very happy to do it. I'm glad it was able to be appreciated by so many of you. Thanks for helping to make it special. As to your actual question, while they did have some of the Apollo landing sites in their view based on their trajectory, it sounded dubious as to whether they would be able to image the specific pieces of Apollo hardware that were left on the moon with this mission. Of course, we'll know for sure once we get the images back down, but it sounded like that was A, not explicitly a science objective, and B, may have been difficult to be able to zoom in enough to get those small features on the moon's surface. But we'll see. Would love to be happily surprised in that regard. Believe the Apollo 15 landing site was one of the areas that the crew passed over earlier today, so Maybe we'll see one of the moon buggies down there. That'd be cool. Again, if you're just joining us here with our special live coverage of the Artemis 2 lunar flyby, you might be wondering why we are able to see the Orion spacecraft, and we had a couple of views inside the capsule, but it's been a minute since we've actually heard from either the Capcom, Jenny Gibbons, or from the Artemis 2 astronauts themselves. It's because we're in a bit of a comms blackout and a handover from one ground system to another. So the terminology is that they are in forward communications or forward comms. Essentially, the Orion spacecraft and the crew on board can send communication back down to Earth. Houston just can't send verbal communications back up to Orion for the time being. And that will continue a little bit into the eclipse period that is about to start in just about 6 minutes' time. And you can track that progress in the upper right-hand corner of your screen. 6 minutes and counting. Time now is bottom of the hour, 7:30 Central, 8:30 Eastern, 00:30 UTC. As the clock in the upper right-hand corner is accurately counting down to the start of the planned eclipse period, the angle that we're seeing here in this visualization may be slightly off, if you will, or slightly differing from the eclipse experience from the perspective of the Orion spacecraft, where it is in actual space, as opposed to this visualization representation of where it is in space. This is a view from on board the Orion spacecraft, and one of the solar panel GoPro cameras that is at the tip of one of the wings. So roughly 3.5 minutes to the start of the eclipse period. This is one of the rare opportunities where you can say you can safely stare at the eclipse as it's happening. No eclipse glasses needed. Well, at least for us. The crew on board Orion definitely need to be wearing their eclipse glasses. And again, this visualization, you can see the sun just peeking out from one of Orion's solar arrays. Coming down to the final 2.5 minutes before the eclipse period is scheduled to begin. Now 30 seconds to official eclipse beginning. We can see the sun's corona. This, if we were seeing this on Earth, would be the diamond ring, I believe. Sun now slipping behind the moon from the perspective of Orion. The first planned eclipse opportunity to be studied in a scientific perspective on a lunar mission with humans. Now underway. This would be a reverse diamond ring, I suppose. Again, the picture in the big box on your screen, this is the view from the Orion camera on the solar array, one of 4. Artemis 2 astronauts, I'm sure, back at the windows and getting ready to snap, if not, they're not already firing away lots of pictures and taking observations of the moon with their various Nikon cameras, including the Z9 that we heard about that the crew was quite insistent to make it on board this mission, and hopefully it will pay dividends once we see the images that come out of it.
science, integrity, and the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon, you could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reid is in window 2 with the long lens, and Jeremy is describing it in window 3. And it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
The voice you just heard, Artemis 2 pilot Victor Glover describing the moments captured by the crew, both visually and just in their sensation of this experience as the sun slipped behind the moon. You could still see the little peak of the corona, but it sounds like from Victor's description that given how dark it is for them and their ability to see a much bigger piece of the moon from their view out the window, that the corona can really be seen cresting around the full width of the moon. Also remarked about the brightness of the Earthshine, which is the reflection of the sun from the Earth back towards the Artemis 2 astronauts inside the Orion spacecraft. Of course, we've seen Earthshine really stand out as we've watched astronauts conduct spacewalks outside of the International Space Station, and for those who have flown up into low Earth orbit, like as we heard from Dr. Sian Proctor in our conversation in the run-up to launch, just how remarkable she felt that the Earthshine was for the inspiration for crew. This a unique vantage point for the Artemis 2 astronauts, really getting that distant sensation of how prominent Earthshine can be, even from out near the lunar sphere of influence, some 252,000 plus miles away. The reason we didn't hear communications from the ground back towards the Orion spacecraft is that, as you heard Victor mention, they are communicating in the blind so that they are able, the astronauts are able to communicate back down to Earth, but the ground is not able to communicate back to them. And the way we're hearing the audio from the spacecraft is such that we have it configured where we are just hearing the Earth-to-ground communications. And so if the ground isn't, or said Earth-to-ground, same thing, the Earth-to-Orion communications, if it's not a two-way comms street, we would not be hearing Jenny Gibbons, the Capcom, or Dr. Kelsey Young, the Artemis 2 science lead, communicating back up to Orion, because that's just not possible at this moment in time. Nearly 8 minutes since the eclipse period began, and you can still just barely make out a little bit of the sun's corona peeking from the edge of the moon there. It's remarkable that we can still see it at this point in the eclipse. The eclipse is set to last about in just shy of an hour's time. Of course, as we continue to hear comments from the crew, we will pause commentary at any juncture in which that happens. We want to make sure that all of you are able to hear along with us the words that are being spoken by whoever is at the mic at this particular moment, getting these observations and able to relay them back to the rest of the world.
Science integrity, the window team is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine, and it is amazing. The brightness where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
Time now 7:49 p.m. Central, 8:49 Eastern, 00:49 UTC. If you look in the big box right now, you see just a little tiny dot there near the upper part of the screen in the left third line, if you will, if you split the screen into vertical thirds. That, according to NASA, is the planet Venus that we're looking at right there. The Artemis 2 crew were given the ability to shoot a number of
Science integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface. And Reid reports he's seen 2 meteors. Science. science, integrity, and the blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon is where, flying through this trajectory and then the sun's going to come up out of the other side. I think we're starting to see the glow around the moon get balanced out. I still see Earthshine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear. Thanks.
Copy. Victor, we're handing you over to science for some critical questions. Thanks for your reports. Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reid observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reid, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
Are you still with us, Houston, or do we lose you?
Integrity, I hear you loud and clear. How do you hear me?
Okay, we got you loud and clear. One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon,
you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon.
Incredible to hear, Jeremy. Were you able to actually pick out any discrete features on the lunar surface? And if so, how do they look different than when you observe them in solar illumination?
No, we really haven't been able to identify features on the lunar surface yet. We just see, the topography on the limb. For the Earth glow, we're about a quarter moon, waxing quarter moon, if you will, from the Earth glow perspective, and it's just at a very, just the sight angle. I'm just not able to tell what I'm looking at yet in the Earth glow.
Understood. Thanks, Jeremy. One other question for you on the solar corona. Were you actually able to see any structure or color in the corona before most of it disappeared behind the moon?
Yeah, I didn't pick out any color, but definitely structure. There were streamers, and they were not uniform at all. For me, the 5 o'clock position, there was just this constant streamer. It would change in intensity and diameter, but it was always there, and it was always at the 5 o'clock position. I only saw one plume, and it came out of basically the 3 o'clock position of the sun. That was very short-lived when I could see the plume.
Exactly what we were looking for. Thanks, Jeremy. And a heads up that we, calculated here on the ground about how long you could see the corona for, and we expect it to start to appear again in the next 11 minutes. Thanks for those amazing descriptions.
Okay, we're excited to see it all again.
Integrity Houston, we're following along as well. That was outstanding. If you haven't already, just reminding you to swap positions at the windows. And that brief LOS we had previously was due to a data rate change expected.
Okay, we copy that, Jenny.
Integrity Science, one more request for you. While it's still fresh in your mind, any annotations or sketches you want to make of what you're seeing either around the corona structures you just mentioned or even on Earthshine would be so appreciated.
Okay, Kelsey, it's going to be pretty hard to go look at a PCD right now, but we'll definitely try and annotate what we saw.
And if the annotations come in the next block where you're cleaning up your documentation, that sounds like a good plan to me.
Time now 8:09 p.m. Central, 9:09 p.m. Eastern, 01:09 UTC for those joining around the world. You'll note that our clock in the upper right-hand corner of the screen has shifted from the clock that was counting down to the start of the eclipse and then the time elapsed since then. We have shifted here to the countdown from now till the end of the planned eclipse period.
Okay, science, we're getting set up for sunrise. The window teams are, Christina is supporting, and also Z9 in window 1. Jeremy's got the long lens in window 2, and the short lens in window 2. And Reid is in window 3, and he has started recordings and is set up to see Corona.
Great sit rep, Victor. That sounds like a good config, and we're showing coronal effects start to appear on your video camera. So in the next few minutes, we should start to hear your observations.
Science and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing.
Amazing. Thank you, Victor.
And just one more logistics note, we have gone as dark as we can in the cabin. We have turned the DUs all the way as dim as they can go, so you can't see anything on the screens. Every bit of light in the cabin affects the view. You're definitely seeing the brightness go closer. It's definitely brighter on the Earthshine side, and so we're expecting to see some corona here soon.
We copy all. Excited for what you see next.
I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but right off the well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet. That line of planets, there's something a moon diameter to the left, and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So. But anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window. And now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Hiker's doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
this is just absolutely beautiful and inspiring to hear. And Victor, we suspect what you're seeing is Saturn and Mars. That reddish object is likely Mars. Good opportunity to look to the future of where we're going.
Yeah, we can absolutely see the color of Mars. That's awesome. Okay, and from this vantage point, the 4 o'clock on the Earthshine side is definitely getting brighter, still no coronal structure.
Houston copies.
As we're hearing these comments from the Artemis 2 astronauts, simply gobsmacked by what they're seeing, as Victor described it. Quote, humans aren't evolved to see what we're seeing. It's hard to describe. It's truly amazing. What we're starting to see.
We aren't able to distinguish which Mare is, but we can clearly see Mare in the Earthshine.
We copy.
You're just starting to see the glow of the sun as it begins to peek out from the other.
We have not seen an impact flash in the last 5 minutes.
Sounds unlucky, but you had a pretty strong start, so we'll take it.
And actually, right after I said that, right at the South Pole, near the South Pole on the Terminator, Reid just saw one.
Amazing.
Got about 13 and a half minutes remaining before the official end of the eclipse period. You can track that in the upper right-hand corner of the screen. What I was just starting to say is that
integrity science, and as you look around our solar system neighborhood, you should see Saturn setting behind the moon right now.
We do. We've been watching it track close to the horizon, and it's right tangential to the moon at this moment.
just about 11 minutes remaining in the eclipse period as
Okay, the
you've
light
been...
is continuing to grow in intensity. At about the 4 o'clock position on the, sorry, about the 8 o'clock position on the Earth-shine side. Saturn has set. Mars is tracking towards the moon's horizon.
Integrity Science, we copy, and we're starting to see it on the vehicle stream. Looking forward to any coronal observations you can share with us.
As we're awaiting those coronal observations, want to call out a specific super chat comment that we just got from Vincent John Florio with a $5 super chat. Thank you, Vincent. Giving some nice new and relative updates to the classic song, You Are My Sunshine. But for the Artemis 2 astronauts, you are my Earthshine, my only Earthshine. You make me happy when moons are gray. Thanks, Vincent.
And science integrity, still no coronal structure at this time, just continuing to grow in intensity.
Copy, Victor, and reminder, you still should have several minutes before the eclipse classes need to go on, and we can send you up a reminder when you're getting close to take your eyes away from the D5 viewfinder, but you should be good for several more minutes.
Copy, thank you, and yes, please send up the reminder. Thank you.
In the realm of Earthshine related either made-up lyrics or actual
Okay,
songs.
we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earthshine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
Just to close the loop of my previous comments, the $10 super chat from channel member Wolverine Warlord saying, "Hey Will, don't forget the actual song Earthshine by Rush. Jeremy would know them since they're Canadian." Maybe they'll do a special rendition of Earthshine. Have Jeremy as a guest on that re-recording. Sun becoming significantly more prominent, peeking out from behind the moon.
We are definitely starting to see structure. That baby hair is rapidly growing out toward the 9 o'clock and the 8 o'clock. It's almost as if it were reaching out for Venus or for the Earth. if you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity Science, glad to hear you're following your training of tell it like you see it.
So far, it's pretty symmetrical. There are 2 or 3 streamers that are growing in intensity and in magnitude, and it's slowly starting to widen, starting to spread out across the horizon. Pretty amazing view.
And Integrity Houston, great words. Reminder for you, we are approaching the brightness level at which you should no longer be using the viewfinder on the D5.
Integrity copies, and thanks for the heads up. Oh, and I think we're seeing some directionality. Some of it is going in different directions because it appears to be moving and combining and recombining as it it's pointing in different directions, and some of it appears to be going like down toward the south pole of the moon, but it's and then coming back together and going out towards Venus and the Earth. And depending on how I stare at it, it looks like one large structure, but then it definitely has wisps, and you can see 3 or 4 structures inside of it. It's like watching a flame. It's like looking at a flame, and stand by. And so it has some inherent movement. Now there's a very bright spot. There's a very bright spot in the center of it. There's a towering light of.
And boom, there's the sun.
And then there were like 2 streamers that were going 30 degrees out from it, and now it is just extremely bright.
Houston, copies all.
Starting to get a little warm.
And we copied all. We wanted to remind you at this point on the eclipse glasses. Should be about time for those.
Houston, we copy all. We are in eclipse glasses. That was an absolutely spectacular, magnificent experience.
Thanks for the report. We sure wish we were there with you.
And Houston, if you could give me about 20 new superlatives in the mission summary for tomorrow, that'll help my vocabulary out a bit. Thank you.
We will solicit input from the team.
Integrity Houston, back with you after a data rate change. Regarding the SAW-3 camera T low caution, no action for you. It just got a little cool during the eclipse.
Okay, we copy, and if you didn't copy my request for the mission summary to add about 20 new superlatives to help my vocabulary, I would appreciate it.
We copied it fantastically.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So you all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reid. Thanks so much.
Integrity Houston, understand that you are still reflecting upon and consolidating your lunar observations. At your convenience, I have 2 items related to the upcoming VIP event.
Go ahead.
All right, first we wanted to let you know that the message for that upcoming event is on board for review at your convenience. That's message 3.06.04. The second item is that we've seen a couple of video blips in previous events. So during the HDPAO setup activity, we're wondering if Jeremy could please confirm for us that the TS rate is set to 1300 when you get to step 10.
Okay, Jenny. Yeah, we're pretty sure we've been in 1300 for all the PAO events. We've been tracking that when we swap between the HHP and the D5.
We copy, Jeremy. Thanks. And for the record, the phenomenal Jenny has gone on to her next appointment of the day, and you've now got Tess with you.
I'm sorry, Tess. Great to have you on board Integrity.
No worries. Happy to be here.
And as you just heard, the communications from Earth to Orion, Jenny Gibbons, the Capcom who's been carrying this coverage through today, and the lunar flyby alongside NASA astronaut Stan
And
Love.
Integrity, 3-minute warning for the maneuver back to bias tail to sun.
Those 2 Capcoms are now departed, having wrapped up their shift today. You're looking at Capcom Tess Caswell, who is scheduled to be working alongside NASA astronaut and Artemis 2 backup astronaut Andre Douglas in this, what is known as Orbit 2, which is the second shift for the 24-hour continuous coverage cycle here in the White Flight Mission Control Room. The Capcoms who will be picking things up in the overnight to morning hours as the crew enters into their sleep period. That will be Capcom's Amy Dill alongside Daniel Serber. And then following that, Orbit 3 on Flight Day 7 will pick it up with Stan Love as the primary Capcom. And with a very busy day now in the books, we're going to go ahead and wrap things up here for us in our dedicated live coverage of the Artemis 2 lunar flyby. Of course, we will continue to keep up our 24/7 live stream Artemis Live, and we'll have the Earth to Orion communications available for all of you there in that format. Really want to thank all of you who supported our channel with the super chats and all the nice comments in the live chat throughout the day. Sorry we weren't able to get to every single one of them, but know that we will go back and read them, and we certainly appreciate all of you who are continuing to support what we do here at Spaceflight Now, especially when it comes to big mission coverage like this on the ground. It is, as you might guess, not a cheap endeavor, and we certainly appreciate those of you who are able to support us in that way. For those of you who are catching this on the replay or just want to support us outside of live coverage opportunity, you can always go to our website, spaceflightnow.com/donate. And there you can see a description of how we use the contributions from you, dear viewer and reader, in our on-the-ground journalism, trying to bring you the best and robust possible coverage, especially when it comes to big reporting opportunities. A round of applause you can see there in the control room as the flight controllers who have been working hard here on Orbit 1 are now departing Orbit 2, taking the wheel from here. I want to give a big shout out to our moderators in the live chat who have been helping us out throughout the course of our coverage, to Astro Joe and Jeff Hansen principally, who have been with us for the duration, and thanks to the rest of the moderators who are able to support through our Artemis live coverage. Thanks as well to channel member Cumulus Granatus, who's been in the chat as well to answer folks' questions throughout the course of today. Big thank you, of course, to our team behind the scenes who have been doing a lot of various activities to make sure that the broadcast has been as seamless and dynamic as possible. To John Pisani and Adam Bernstein, Michael Kane out there as well, and to our Spaceflight Now editor, Stephen Young. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Again, we will be here in Houston through the return of the Artemis 2 crew, seeing a safe splashdown off the coast of San Diego coming up in just a few days' time. I'll give a last word to Jesse Pereira with a $10 super chat, saying I just want to give at least a big thank you for the live stream, and just to say how honored I am to be able to watch all this live. It is so cool. And I will say it for myself, and speaking on behalf of the team, it has been very cool and an honor and privilege to be with you all for this day in history. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Remember, be good to yourselves, be good to others. We will see you next time, folks. And until then, bye-bye.